It's the
Wow.
beginning. Yeah.
Perfect observing weather.
Yeah, that's a way to look at it.
I like winter observing. I like the 10 and 11 hour nights. It's
Hmm.
fantastic.
Yeah,
Just got to dress for it. That's all.
that's all. Yeah.
I love it if it's clear. It's the 10 or 11 hour nights when it's snowing or raining repeatedly for days on end that get boring.
Now, I pulled an 11-hour session last year when it was -2 wind chill,
Wow.
about 8 degrees, and I managed the whole night. It's
-2. That hurts.
well, I spent a year in Alaska and did a lot of mountain climbing and skiing, so I know how to
Oh,
dress for it. So
yeah, you're well dressed. You're okay.
yeah.
Mm.
I decided to give up that pastime of sitting out in the cold. It's not really the cold that bothers me, it's the wind here, where we're on the mountainside. Yeah, the wind picks up, and that's the real issue.
Mhm.
I didn't say anything about wind.
Yeah.
When the wind's blowing and it's that cold, I'm not out there. No.
Yeah. Yeah. Let's just say that when I was younger, I was more into it in the cold, but as I get older, I don't know. It's get hard.
I think you have more enthusiasm when you're younger. That's all it is. The enthusiasm dies down a little fraction.
Yeah, the enthusiasm to curl up in a nice warm bed, you know.
Well, yeah.
Mhm.
So, Chuck, your group liked the presentation, you said?
Oh my gosh, Norman,
Yeah.
it was fantastic. I
All
mean,
right.
I'm still getting comments even to today.
All right. Good.
Yeah, I mean, it was just incredible. I'm so appreciative. I can't express myself.
See, the presentation I gave you this week, today I'm going to do another presentation that comes before that one. I've done that one in early 2009 or something, 10, up to 2010, and it was originally in French because I was presenting that in Quebec here.
Sure.
And this afternoon, I've spent half of my afternoon just trying to translate all the headers of the other presentation in English. So, but what you will see tonight is the before the section that I presented to you.
Yes.
The very early days, a trip in the memory lane here. Makes me feel older too. Jeez.
Uh,
What makes me feel old is when somebody says, "Have you got something from such and such a date?" And I start going through the hard drives and look at how long I've been doing this.
I was sitting with a group of amateur astronomers, some of whom were in high school, and some were my age. And a couple of my friends were talking about things that happened to them in the 1960s. And after the meeting, I said, when you talk about 1960s in front of these kids, it's like when you were in high school talking about somebody talking about 1905.
Yeah, right. Yep. Put things into perspective. Yep, we're getting there.
The thing is that the 80s and 90s and that, they seem like yesterday. They don't seem, 30, 40 years ago. That's the thing.
Well, that was 30 years ago.
Yeah.
And yet right now, 2019 seems like 40 years ago.
Yeah.
Yeah.
Yes. You're right.
These kids on the program right now are just going, what?
What are they talking about?
Yeah.
Huh? Yeah. Don't worry. You'll blink your eyes and you'll be 50.
Yeah.
Yeah.
David,
I can
when I
always remember.
first met, you were quite a bit older than Libby is now, but you were probably about twice as old as Libby is now when I first met you, David.
Yes, that's right. Yeah. Yeah. That's getting to be some time ago now, isn't it, David?
Mhm. Well, I got my energy.
Good for you.
You,
Yes.
you've proven Einstein correct again.
That's right.
That mass and energy are interconvertible.
Mm-hmm.
Hmm.
And I am getting more mass.
But you can run around the room 80 or 100 times and burn it off.
And I do. I do. Who do we have watching us here? We got James the astrophotographer, Stefan Delprat. Um, they're wishing us a happy Global Star Party. Aaron Thompson, greetings all. Looking forward to another fun night.
All right.
Yeah. Book Davies, hey, hey, space monkeys. Where are the space monkeys? Yeah. Martin Eastburn says hello. Norm Hughes, good evening, everyone.
Good evening.
Yeah. Ed Gunther, 23 degrees and overcast in Plattsburgh, New York. Good time for a Global Star Party.
Oh, I'm glad Ed Gunther is here.
Yeah.
Mhm.
I'm
Right.
really glad he's here.
Hmm. Martin Eastburn, I spotted the moon through the clouds, got out the app, and it was planets aligning along with the moon. Nice.
Well, the sky here tonight in Montreal is pristine. No clouds whatsoever. It's a
Hmm.
beautiful night for observing the moon and the planets.
Hmm. Finley's astrophotography says hello.
Hello.
Yeah, hello. Martin Eastburn says, I know adults think 60s and 70s are very old. I think 50s are old. Oh.
Oh, ouch.
Ouch. That's right.
Welcome, Molly.
Yeah.
Hello, I have arrived. How is everybody?
Good.
Very
Hey,
well.
Molly.
Good, hi,
Good
Jerry.
times.
It's going to be a clear night here again, so got my telescope set up
Hey.
outside.
Great. So what we'll do, uh, we will sprinkle in some like 2-minute live views, of whatever's through a telescope
Sure.
until we get to the hardcore astrophotography crescendo. Hmm. Gary, what's your sky look like out there?
The usual rain.
Usual rain.
We've had a couple of odd nights clear. We've got a bit of rain coming through, and then I think it looks like it's going to clear up from tomorrow night for a couple of nights.
Yeah,
But it's that time of year. Yeah, we just get
I
the
see.
change of seasons, and the jet stream's slamming right into the UK at the moment, and I happen to be right where that lands. So
Hmm.
yeah, it's just a case of take it when we can get it at the moment.
Sure.
I got some great views of the sunspots today. I had some excellent seeing this afternoon, so I'm going to be
Oh.
processing those images.
Nice.
I'm
There
actually
is
just
a
processing.
humongous sunspot
Yes.
just
yes.
coming on.
Yeah,
Isn't
so
that beautiful?
Yeah. So I've got those, and I'm hoping to see the plages that are mixed in with those as well. I just have a white light filter, But the seeing was good enough. I might be able to see the plages as well. So
I saw some of the plages today. They were starting to come on.
Yeah.
Yeah, I was imaging that earlier. Fortunately, it cleared for a couple of hours, but problem here is the sun's so low. It's really low on the horizon, so you're just imaging through all the rubbish.
Oh, it's too bad.
But it's looking nice anyway.
It's time to get started.
Scott.
Hello.
Hey, this is Mike Overacker.
Hey, Mike. How you doing, man? Welcome to the
Not too
Global
good.
Network.
I've got no video.
Oh, you got no video. Okay. Well, you know.
I'm not sure what's going on because I had video
Yeah.
before, and whenever I started to log into Zoom,
Yeah.
I've lost it. How you doing, Norman?
Good. Hi.
Do you
Yeah,
have
so-
another device open that like Skype or something that might be hijacking the video just in case?
I've it's given me an error. I'll bring it up there. You can. Oh, it doesn't show it now. There it is. It's giving me an error on the
Lost webcam utility. Yeah.
EOS webcam utility. It did that before, and then I was able to get it up, the video up, no problem. And
Right.
then
Well, Mike, why don't you just you can play, try to get it going offline and then just pop back in, So
yeah, I'll try to do that.
okay, yeah,
Okay.
we'll be here.
I'll log
We'll be
out.
here. All right, take care, Mike.
Be here
All
for a while.
Okay, we're gonna go ahead and get started. It's already 7:00.
8 o'clock.
Okay.
From Voyager, Titan was so unusual. All we could see from Voyager is this hazy world we couldn't see through to the surface. And that's why we had to go back with Cassini carrying the Huygens probe to try and see what does the surface of Titan look like. So the Huygens probe parachuted through in 2005, and we landed on the surface and we saw an amazing world. It was incredible how Earth-like Titan appeared. It had river channels, it had lakes, it had sand dunes. The only difference is it's very cold on Titan, and the liquid that flows through Titan's rivers is methane instead of water.
The Cassini-Huygens mission has been one of the greatest voyages of discovery in the history of science. We have learned and discovered more things about a previously unknown dynamic system, a system that's 1 billion miles from us, the Saturn system, than we ever could have imagined. One of the pinnacles of that has been the discoveries on Titan. Titan has turned out to be a very complex world. It has geology, it has methane rain, it has lakes and seas, it has dunes of organic molecules, and it has a lot more secrets that it's still hiding from us.
I think that really makes people so excited about Titan is this combination of familiarity and alienness. We've had 126 close flybys with a spacecraft with a dozen instruments that in each of those flybys are all taking data about different aspects of Titan.
Not only was Titan fascinating in its own right, a moon the size of the planet Mercury, it was also Cassini's gas tank. It allowed us to change the shape and orientation of the orbit to explore the poles of Saturn and the rings and all of the icy moons by carrying a lot less fuel than we would have to have carried otherwise. It gave us the energy to go all the way across the rings and fly between the gap between the rings and the planet.
Because of these flybys of Titan, using Titan as a gravitational slingshot, and so many of the other remarkable discoveries that have been made by Cassini, for example, mapping the composition of the plume of Enceladus, would not have been possible without Titan there. We could not have gotten to these places without using Titan.
And so I think Titan has really been a particularly special place to explore just because of all of the complexity in the system and the puzzles that it has given us.
Well, hello everybody. This is Scott Roberts from Explore Scientific, and you are watching the 24th Global Star Party. We have an incredible lineup of speakers, as we always do, and great astrophotographers are here too. And so you're going to have a very pleasant night. You might even hear some music, or you know, somebody's known to have been sneaking in some music into this show. So, but we love it. We love it.
I'm pointed here.
Our first speaker tonight will be David Levy. David has attended every Global Star Party, and I don't know of any organization or club that's run 24 global or 24 star parties of any kind, within a 1 year period. So normally it would be limited to maybe 10 or 12 star parties, so we've, I think we're starting to make some new ground here. David is, of course, if you've been following the show, he's a dear friend. He's a dear friend to so many people in the astronomical world and in the literary world as well. And I was looking at David's book, A Night Watchman's Journey. And I know David so well that sometimes I forget, his remarkable achievements, And so I was reading the back of the book here, and it starts off and it says, David Levy, a native of Montreal and a longtime resident of Arizona, his central role in the discovery of Comet Shoemaker-Levy 9 that impacted Jupiter in 1994 brought him to the attention of news media around the world. I remember watching that whole spectacular event. It was such a heady time that I couldn't stop thinking about these pieces of this comet that was going to impact Jupiter, thousands or hundreds of thousands or maybe millions of people got some sort of a view of this event, whether it was going to be through a telescope, on television, on their computers maybe. That was still an early time. A lot of people weren't really into the web like they are now. But anyways, it was amazing. And, and so it says that unprecedented comet, plus his remarkable discovery of 22 other comets, and his many books and hundreds of inspiring talks on astronomy have made Levy the most widely known amateur astronomer of our time. And that's true, folks. So I am, it is an honor
Bravo.
to once again have Dr. David Levy be here on the Global Star Party and to share his insights and his poetry with us. Thank you, David.
Well, thank you, Scotty, and it's certainly great to be here at the 24th Star Party, and I hope there'll be a lot more. Really getting used to these Zoom cloud meetings. They really, they're hard to get tired. They're hard to get tired of, but they're very, very special. And I also was pleased that you say how I am a friend to so many people in the amateur astronomy and professional communities.
That's true.
And one of those people that I was honored to call friend was the astronomer Bart Bok. And I first read from him when I was, I first read about him when I was a little boy. reading the Golden Book of Astronomy, and some of you may even have a copy of a book like that. I'll bet you Dave Eicher has a copy of that book. I'll bet you Ed Gunther, who is in the audience tonight, might have a copy of that book. I'm glad that he is here tonight to enjoy our star party. Excuse me. Oh, excuse me just a moment. Okay, and I was reading that, and there was a foreword by Bart Bach. And what he did was that he made us see, he forced his readers to see the magic of the night sky. He forced us, he talked about his beloved Milky Way because he and his wife Priscilla were really champions of the Milky Way. And he forced us to see astronomy as a big picture when we go out under the night sky. So you can imagine when another friend of mine, Peter Jedicke, was visiting Arizona, and I was driving him to the airport for his return flight. And Peter said, David, your assignment, should you agree to accept it, is to interview Bart Bach for me. And I said, oh, I can't do that. Oh, no. And he said, why not? And I said, well, Bart Bach is a famous astronomer. He sits on top of on a big throne, and he owns the universe. And no. You can interview. Well, if you want to do it, do it. If you don't, I'll understand. I let Peter off at the airport, and I quickly drove home, and I said, let's get this darn thing over with. I picked up the phone, and I called the number Peter had left me. The phone rang, and Bart answered. Hello, this is Bach. I am just out of the shower. I am dripping wet. I have a beautiful girl in the kitchen who is cooking lunch. So be quick. And I said, Dr. Bach, this is David Levy. Quick, be quick, be quick. And I said, well, maybe I could call you back another time. And he said, no. The beautiful girl in the kitchen leaves later today. I told him what I wanted to do. Be quick, be quick. And he said, why don't you come by tomorrow? And I found out where he lived. He lived on Sierra Vista Drive. So I thought he meant Sierra Vista, Arizona. But that's quite a long drive from where I live. But it turns out Sierra Vista Drive is not far from the University of Arizona. I got to his house and I had a whole bunch of questions to ask him. We sat down. He was a lot calmer there and he didn't go be quick again. And I asked him, I said, Dr. Bach, 20 years ago, you wrote a book called The Astronomer's Universe. And the first 5 words of that book are, astronomy is on the move. 20 years later, how would you assess those words? Would you know I never got to ask another question? He went into this thing about the progress of astronomy over the 20th century. It was absolutely brilliant. An hour went by, I turned the tape over, another hour went by. I had to excuse myself to go to the car to get another tape. And that tape we filled up, there were 2 hours that he spent answering that question. I never got to ask him another question. But he gave me quite a bit to write the article, to actually send the interview over to Peter. I'm not sure what Peter did with it, but I decided that I had enough that I would write an article. And I wrote it for a magazine that David Eicher, who you'll be hearing pretty soon, is very familiar with, Astronomy Magazine. At the time, Richard Berry was the editor. And it was my first major article. And I know he'd edit a lot of it out, but one thing that I'm glad that he didn't edit out was the first words that I wrote. In the beginning, I wrote, there was no Bach, and the Milky Way was without form and void. And I remember we went to Riverside Telescope Makers conference a few months after that, and I was able to meet Richard Berry for the first time. The first thing he did, looked at me, he said, in the beginning, there was no Bach. He said, I'm changing a lot of your article, but I ain't changing that. It was so much fun to see that thing. And that turned out to be the opening lines of the biography that I eventually wrote about him, a biography that is now called The Man Who Sold the Milky Way, a biography of Bart Bok. We got to be very good friends. When Bart passed away in August of 1983, it was really hurting me because I felt I had lost a friend, and I had. I would lose a lot more friends since then, but Bart's death hit me pretty hard. And I remember the one thing he said to his students. He was telling me that story, and he introduced it by saying, by the way, all of my students have to call me Dr. Bok until they get their doctorates. And I didn't have a doctorate at the time. I said, well, what about me? I've called you Bart ever since I met you. And Bart looked at me and he said, you are an exception to every rule I ever made. But this is what Bart advised his students to do. And I think it's the most important advice that any astronomer has ever given any student. And here it is. When you are in an observatory at 3 o'clock in the morning, and you see the clock and it says 3 o'clock, stop your photograph, he would say. Stop your photometer. Walk away from the telescope. Walk down the stairs, 1, 2, 3. Go to the front door. Walk out the front door. Now walk 20 paces, not 21, 20 paces, no more, no less. Then stop. And just look up at the sky, just to make sure you're making bloody sense. And on that note, back to you, Scotty. Thank you.
Oh, thank you very much, David. Thank you. I've been in David Levy's observatory, the Jarnac Observatory, many times, and I believe that there is a backlit glass plate of the Milky Way that was from Bok's collection. Is that right?
Yes, there is. It's out there right now. Mm-hmm. And it has a little plaque on it. And the plaque says Priscilla Bok, November 1975. And I asked Bart about that, and he said that the last event that Priscilla ever went to before she died was the opening of the Flandreau Planetarium. And she died about 4 days after the opening.
Oh.
Weeks after that, the director called him, Bart, and asked him to come back. He said, you left something at the planetarium. And Bart said, well, send someone, bring it to my house. I don't want to leave. He said, oh no, you have to pick it up. Please just come. So he came, they walked him into the theater, and they showed the chair that Priscilla was sitting on and a little plaque that said Priscilla F. Bok, November 1975. And I've never forgotten that. He never forgot about that. And that plaque is now on those transparencies that are in the observatory that you've seen, Scotty.
Wow. That's very touching. A lot of history that David's been able to dive into with knowing such luminaries as Bart Bok and Clyde Tombaugh and many others. I hope at one point that there's a compendium of all of David's articles, his Star Trails articles, and all the rest of it that he's written. It's very rich and very personal. Our next speaker is David J. Eicher, and again, this is another great iconic person in the astronomy world. David has done amazing things through Astronomy Magazine, through his Deep Sky magazine before that, and whatever he did before that, I'm sure he was writing about the universe and giving lectures about it and inspiring people about looking up at the sky. His latest book is let me get a little bit better view here. This is not the latest one, but one of the latest ones, and it's galaxies, and the inside the universe is star cities. David was kind enough to do a show with me. We talked a lot about the book and how it was created and everything. What it says about David on the inside is that he's the editor-in-chief of Astronomy Magazine and a board member of the International Starmus Festival, which will kick off next year sometime. He has also written shows for the Adler Planetarium and NASA, and is the co-author with Brian May, rock star Brian May, of Mission Moon 3D, which I think is the latest thing that has recently come out, and is the author of The New Cosmos. David is, approachable, friendly, extremely knowledgeable, and he's been here now on many of our global star parties, helping us understand the universe and explaining it in only the way that David Eicher can. So, David, thank you very much for coming on to our program. I am going to give you the spotlight here. We have a lot of people here in our, it looks like Hollywood squares here.
Thank you, Scott. And thanks, David, for that wonderful talk about Bart. Anyone who ever met Bart Bach knows they don't make him like that. He was really an incredible person, and your friendship with him is very inspiring, David.
Thank you, David. They threw out the mold after they made him.
Indeed. Yeah. And I love to talk about galaxies. And actually, the latest book with Brian is even newer than that one. It's Cosmic Clouds, but I won't talk about that really distant stuff tonight. That's far off. Who cares? It's way out there in the deep. Tonight, I'm going to talk a little bit as we go outward from our talks about how incredible the universe is from Earth. Now we've made it all the way out to Venus. Tonight, a little bit, I'd like to talk just a little bit about Venus. And why did Venus turn inside out, which is a major conundrum, discovery of the past generation about our so-called sister planet. Well, you know that Venus, aside from the sun and the moon, is the brightest thing in the sky. It's often claimed to be the sister planet of Earth, although it has essentially nothing to do. It could hardly be more dissimilar than Earth. It is about 95% our diameter. It's a rocky planet. It's about 82% of Earth's mass Venus has, but after that, the similarity ends. It's 30% closer to the sun. The surface temperature, the first spacecraft that landed on Venus discovered, was in excess of 800 degrees Fahrenheit. That ended speculation that there might be life on Venus. Of course, we had stories not only about Mars, but about Venus and essentially everywhere else we wanted to find life looking back at us. The surface pressures on Venus, of course, are also crushing. They're about 90 times greater than the surface pressure on Earth. So it's a very, very cruel and hellish environment, the planet Venus on the surface. It has a 90 to 95% carbon dioxide atmosphere as well that has undergone a runaway greenhouse gas carbon dioxide heating the atmosphere of Venus. So it's a nasty place. And we really discovered the details of how un-Earth-like it is beginning in 1966 when the Soviet Venera 3 landed. It and several other landers operated briefly on the surface of Venus before they gave way, and they returned a lot of basic data about what our so-called sister planet is like. The story really turned on a dime in a big way almost a generation later. In 1989, NASA launched the Magellan spacecraft, and it was a radar mapper and a very sophisticated craft that studied Venus in the early 1990s quite extensively. This mission produced a lot of surprising results about Venus. The most incredible came when it really mapped the surface of Venus in detail for the first time underneath that thick, cloudy, carbon dioxide rich atmosphere. unless they have active resurfacing like our Earth does. We have a lot of erosion and resurfacing processes on our planet. So we don't see the early record of what happened in the inner solar system on Earth very much. It's very difficult to see. But of course, one good glance at the moon or at Mercury or some other body shows that the inner solar system was an incredibly dangerous, violent place that underwent this so-called late heavy bombardment. Early in the history of the solar system, those craters are still very abundant, looking out at the moon even with a pair of binoculars. And the thing that really stymied planetary scientists early on in the close examination of Venus was that it lacks craters. So why is that? What happened with Venus? It's in the inner solar system. It's 30% closer to the sun than we are, than the moon is. How could Venus be almost devoid of craters, have a very small count of craters? Something serious and in a big, big way happened to the surface of Venus. So that was a major mystery to investigate starting in the early 1990s. On Earth, of course, we have a lot of processes. One of them that's important is plate tectonics. That plays a major role in our evolution and helps to resurface our planet. Moving plates sink on Earth by subduction. That carries a lot of water back into the interior of our planet. On Venus, however, plate tectonics either existed very briefly long ago, or it never existed. We don't know for sure, but it doesn't exist now. And so because of this, continents, ocean basins, systems of ridges, plate boundaries, all those things that kind of mark our Earth and how we think about land on our Earth, the continents that we're on, they don't exist on Venus. It just doesn't happen. So the real puzzle was that on Venus, the data showed from Magellan that the surface is very young. And it wasn't clear why that is at first. Craters existed, some of them, a small number, but the planet didn't disappear during the late heavy bombardment. So what exactly happened? Without that erosion, without the plate tectonics, there was really one major culprit left, and that was volcanism. So to cut to the chase here with a lot of research that followed Magellan, Venus had enormous volcanic activity in the past. And in fact, the cratering record pointed toward a major, if you will, a catastrophic resurfacing of Venus that happened sometime in the planet's distant past. And it's thought that that was something on the order of between 500 million and 1 billion years ago, and closer to 1 billion years ago. So somehow the planet catastrophically resurfaced with lava, with volcanism, the better part of 1 billion years ago. You can put it dramatically in the terms of understanding planetary science that it was a catastrophic resurfacing. The kids who like to have fun with planetary science like to say that Venus is the planet that threw up on itself. You'll forgive me for that. It's a little crass to say that, perhaps, but that's one way to put it, okay? Because it was a catastrophic planet-changing event. Now, why is that? What happened? We still don't know why this cataclysm happened on Venus, and especially when it did. Clearly, it had an enormous amount of stored energy that lasted for a long, long time in the interior of the planet. And at some point, some triggers happened, and that energy was released, and it burst outward, and much lava spewed forth, and it made the Venus that we see today. We don't know why it happened. As I said, when it did, the timing of this is a complete mystery. What instabilities existed that suddenly gave way. But less than 1 billion years ago, and let's just think about this for 1 minute. This is something on the order of when animal evolution began on Earth, when the first protozoa appeared, as animals were just beginning to evolve on our planet. our neighbor, our sister Earth-like planet that's nothing like Earth, had this incredible, violent, enormous event going off with no one there to see it. An event that we're just beginning really to understand today, nearly a billion years later. So there's the real mystery of Venus, is that it's not Earth-like at all, of course, but it gives us one of the biggest puzzles. We talked about how we think the moon formed from a giant impact, and we know that Venus had this cataclysmic resurfacing. We don't know exactly how either of those started yet, but as we go out in successive weeks here, farther out into the universe, we'll have more puzzles and more results to explore. So next time you look at Venus, remember that it is a terrible place, and it's also the planet that completely reconfigured its surface. Thank you, Scott.
Will do.
If I could just make a comment right away here. I was listening to your wonderful presentation, David. They get better each time.
Thank you.
And but I was thinking of one of your visits here, when your dad was around. You and your dad, and I know how close you were with him, came over, and I believed we watched Lincoln, the movie, together.
Yeah.
Knowing how much he loved the Civil War and how much he admired Lincoln and how much you admired Lincoln. And then just suddenly I'm listening to you talking about Venus, and I'm suddenly thinking about Abraham Lincoln and you and your dad.
Thank you, David. And you know, he admired you and Wendy so much and enjoyed visiting out there. Sorry, don't mean to hijack the conversation here.
No, that's all right.
But what a an extended family that felt like with my dad. He had great feelings of friendship and of love for you guys too.
He was an amazing person. You not so much, but he was. Oh no!
Well,
no.
Sometimes the apple falls a great distance.
Not in your case. It was a real honor to know the man and to know you.
Thank you, David. That's a great memory we have. Thanks so much.
Very cool.
Thank you, David.
Thank you, David and David. Now, what's interesting about this particular star party, this is the 24th Global Star Party. Today is the 24th of November. And in 1924, this week, Hubble had published his book or his theory about the expanding universe. And so that's very, very interesting. And on this day of the 24th, Jeremiah Horrocks makes a helioscope to safely view the transit of Venus in 1639. So it's a lot of, I didn't plan any of this stuff, okay? So
Twilight Zone.
That's Twilight Zone stuff. That's right. That's right.
Scott?
Yes?
Your magic. That's what we're discovering tonight.
Thank you. Well, it is. I just started thinking about all this stuff and was going, gosh, what is the number 24? I need to go bet on 24 or something right now. So anyhow, but I wanted to take a couple of minutes. We have Molly Wakeling with us today, and we have lots of astrophotographers with us today, but Molly has clear skies, and she's got the moon there. So I thought we'd take a couple of minutes looking at the moon before we go to our next speaker, which is Libby and the stars.
Yeah, sure. Let me get that pulled right up here. Give me just a second. All right. So we are looking at a live view of the moon from my backyard here in the Bay Area of California. I have an 8-inch Schmidt Cassegrain, the one that's in the picture there, on my Paramount Mighty, and a monochrome camera mounted on there to look at the moon tonight. So these are some live views here. Now, some of the main features here. So we have the Sea of Tranquility, Mare Tranquillitatis here. And right about in this area is where the Apollo 11 landing occurred and where the lander module still exists. We have down over here in the lower left is Tycho crater, which when the moon is full is very obvious, and you can see the rays coming off of it, all the ejecta from whatever rock slammed into the moon. But in this gibbous phase, those rays are a little harder to see because of the steep shadows, since it's located near the terminus here, the Terminator. And then up kind of in the middle here, this is a large area of what looks like it doesn't have a whole lot of craters, and a lot of this is lava back when the moon was younger and more geologically active, that filled in a lot of older craters. So kind of have this much larger sea. I think it's probably even referred to as an ocean, even though of course there's no water there. And this crater here, kind of in the middle, is Copernicus crater, one that I'm sure any moon observer has observed many times, because it's got a very cool, the edges of it, the way that the rock has slumped in on the sides kind of gives it a really cool, rigid edge with lots of man, words are hard for me tonight for some reason. lots of interesting texture on the sides of the crater there.
It's a terracing, I think you're talking about, terracing on the walls of the crater.
That's a great way to describe it. Yeah. And I know that like diligent moon observers have terms for all of these things. I'm not a selenite myself, but I do appreciate a nice view of the moon. I just haven't studied it in great detail.
You're always welcome to call on Jerry Hubble, if you...
Excellent.
Yeah. Great. Okay. All right. So our next speaker here is Libby and the Stars. Libby's been actually here at Explore Scientific for the last couple of days, and she wanted to come here and get closer to what we do here at our facility, and she's been helpful. She's helped put together orders that are going out. I'm sure it would be the recipient would be surprised to know that a 10-year-old helped get their order on its way. But Libby also she did some recording today and showed kind of an out-of-the-box experience of a 4.5-inch Newtonian telescope, and so they're putting that video together, and I hope to have it in a couple of days. It'll be fun to show Libby what she's done. But Libby, you are giving, I can't remember which number of presentation that you're giving right now, but your presentation is about black holes, right?
Yeah.
Okay. Yeah, Libby, we can't hear you very well. Maybe you need to get closer.
Is that better?
That is way better.
Okay. So I know the theme is expansion, but I'm going to talk about depth of our universe. It's not really a lot of depth, but a lot of sci-fis might relate to black holes. Some sci-fi movies may relate to black holes, and a lot of people won't think it's real. Well, it's real. I mean, it just doesn't seem real because the thought of getting sucked up by a giant hole in space doesn't seem real. I mean, most of the stuff out there, people won't believe it's true because, I mean, it sounds crazy and everything. Well, it is true. And a lot of black holes, I find them really interesting. And I think the younger generation, a lot of that stuff gets them interested into astronomy, because I think the thought of someone getting sucked up by a black hole sounds like, I don't know, it sounds like unrealistic to some people, to where they want to start doing astronomy to learn more. And I think they're pretty cool. I mean, they're not the brightest of subjects to talk about, but I mean, they're awesome to observe and everything. And I know I've been looking at black holes the past couple of days, but I just figured out there's one only 1,000 light years away, which is pretty close, which is right down the road from us in galactic terms and everything. which is pretty scary. I mean, if you're gonna be like, hey, there's a black hole that's gonna come suck us up and we're gonna all die in a couple of years. I mean, it's a little bit scary, but I don't know what people think. Like, it's scary, but when you really think about it and you start learning about them, you're like, hey, that's pretty cool. Well, at space camp, we would have these little meetings every day about before bedtime, and the lady would talk to us about the Orion Nebula. And now in the Orion Nebula, there's black holes and a lot of that stuff. So I asked her at the end, and I said, what happens if you get sucked up by a black hole? And she went, you get spaghettification. And I was like,
real
say that 10 times really fast.
I see it in a textbook. It's a real term.
And I didn't think that was true. And so when I got home from space camp, I of course wanted to search that up because I mean, spaghettification, what the heck? I mean, that doesn't sound real. I mean, it's not like you can just be like, oh, we're just gonna get spaghettified. I mean, who even came up with that name? So of course I started to have to research about this. And I started wondering what happens when you get sucked up in a black hole. Because I know a lot of the sci-fi movies out there will be like, your face warps or you turn purple or you go look crazy. But I actually found the real, like, what actually happens. So spaghettification is actually a real thing, and you will get stretched out, and the radiation will stretch your body all out and all your muscles into the black hole. And I thought that was pretty cool. I mean, that's a lot for a 10-year-old to be researching. And then just randomly get the answer of, it's spaghettification.
Mm-hmm.
I thought that was really amazing because a lot of sci-fi movies, I like a lot of sci-fi movies, and they don't really like give a real answer of what happens when you get sucked up by a black hole. But I thought this was pretty cool because, you know, it doesn't sound real. You know, now someone won't even believe it's something in the real world that's like simple. They'll be like, oh, guess what? This happened. No, that didn't happen. You'll get spaghettified. I mean, it's hard to believe. It's really cool to think about it though, and I think it's really nice for the younger generation. That's one of the things that got me interested in space because I thought, wow, that could actually happen. Maybe if I researched it, I could do something, you know, to learn more about it and do some more and like advance in learning about black holes. And the other day I was still researching about this because I'm still wondering, like, this is a hard subject. It's a hard thing to process that you're going to get turned into a noodle if you get anywhere near a black hole and that radiation. And so I looked it up, you know, all that stuff. And I was wondering what would happen if you get like, what happens, like, do you come out of a black hole? You don't just come out in like a noodle in space. And I came up with the idea of a theory to where basically your whole body gets stretched out, it's just all torn up. And then since we're made out of the same stuff as stars, when we get from out of the black hole, all our stuff will just disintegrate in the galaxy. That's why I'm going off of my theory. I know there's many theories out there. That's what I came up with based on the research that I have. It's a lot to take in, that spaghettification. And I was wondering about that name too. You know, regular NASA terms would be like radiation and lunar observations. But this one just sounded a little bit off because it was spaghettification. You know, spaghetti. I wonder what NASA worker thought, like, oh, hey, maybe we should call this spaghettification.
Libby, have you been able to see like the first image of a black hole that was published?
Yes, I have seen a image of a black hole from, I have not seen the first. I'm not sure if it's the first or not, but it's from Orion. And it's so cool. You can see like redness around it.
Mm-hmm.
And a lot of what people think of as black holes and what they look like today, it doesn't really make sense because they think it's just like shiny, like there's a little shiny mark and it's just rolling around, stars are twisting around it and everything from radiation. But what I found from the Orion Nebula for NASA, I was shocked. And like the next day, I was telling my friends, like, this is a black hole and you're going to get sucked up by it. You're going to be spaghettified. I was like, this is pretty cool. It's red around it and it was so pretty. I mean, it's hard to think that something that can suck you up and like tear you apart and get spaghettified, but it's so beautiful. I mean, I know we're probably not that close to it, but that was beautiful it was beautiful to see I mean, it's beautiful to see death. And I was really I was kind of surprised because what I see when I look at black holes are usually like cartoon lights, and there's just like stars are around the black hole. It's just black, and I was like, that's what I had set in my head, like my expectations for what it would look like, but it was a lot more different. I know it's kind of like a fun thing to talk about my age at playgrounds. Kids, they like the idea of like black holes and stuff. I know that's one thing that they're really interested into showing me. If there's gonna be one thing that'll get kids interested into showing me, that's really it. For at least my age level, because I mean, the kids don't want to learn about Saturn. They want to learn about something that you can get spaghettified from. Something that can suck you up. Space vacuum.
Wow. Okay. All right.
That's how Scott was.
Libby, thank you.
Scott was 10 years old. He liked the idea of getting spaghettified. He didn't call it that, but he liked the danger.
He just liked this idea of being stretched beyond belief.
Yeah, you like blowing stuff up too when you're a kid.
Yeah, that's right. So Mike Overacker was finally able to join us. I'm glad you got your video fixed. That's great. Yep. So thanks for joining us. Our next speaker is all the way from Nepal. Okay, DT Gautam, and she has. In her last two talks, she gave talks about satellites and the importance of satellites in our society and the technology that they bring. We were talking earlier. She said, I want to come on, but I'm not sure what to talk about now yet. I said, how about the expansion of the universe? And so she's put together a great presentation about the expansion of the universe, and we're going to hear it all the way from Nepal. DT, thank you for coming on our program.
Thank you, Scott Robert, and hello to everyone.
Hello.
As something about the expanding universe. Okay, let me start. Actually, initially the universe was thought to be static and not expanding. Yeah, and when Albert Einstein formulated his general relativity equation, it had shown that the universe was expanding. But when he talked with many scientists and astronomers of that time, everyone agreed that the universe was static and not expanding. Though this made Einstein to think that his theory prediction was maybe wrong. Maybe the thing which is acceptable by everyone, maybe it's wrong. So he modified his theory and he added cosmological constant lambda in his equation that prevented the explanation of universe. But Einstein universe was like a pencil holder with its tips, with the universe was holding the total collapse and forever expand. Later in 1929, when Hubble made landmark observation that showed that the galaxy showed toward the red part of the spectrum, and there comes the Hubble constant, which is not an actual constant since the rate of expansion of the universe is increasing, and the value of the Hubble constant is also a variable. And then Einstein removed the lambda from his equation, referring it as the greatest blunder in his life. But today we use the cosmological constant to describe the most unknown things in the universe, the dark matter, etc. So the greatest blunder of Einstein was having said cosmological constant is the greatest blunder of his life, and this is the history for the haunt of the expanding universe. But this made the Stephen Hawking to think, if the universe is expanding, what if we reverse the scenario in words? It's so the universe exploded from a single point, and this is called the Big Bang, and the Big Bang is formed by the Stephen Hawking. I have some presentation here. Okay. Here is the expanding universe, and this is all dark age, development of galaxy, planet, dark energy, and quantum inflation, Big Bang explanation, etc. On here, I have prepared some one short video. Okay, wait. Are you able to listen?
The universe is getting bigger every day, and what we understand now is that the amount it's getting bigger is getting bigger every day. The expansion of the universe is accelerating. Ironically, what this means is that as time goes on, even though the universe is getting bigger, we see less of it.
How is the universe getting bigger? Finding the answer has become one of the greatest quests in modern science.
Just a few years ago, we were trying to measure how much the universe is slowing down over time. It makes sense, right? An explosion happened a long time ago, the Big Bang.
Scientists assumed the Big Bang would slow down and gravity would pull things back together. But that's not what they were seeing in the cosmos.
Astronomers think that the universe appears to be expanding at an accelerating rate.
Now, we have no idea what's causing this. So I'll let you in on a secret here. Whenever astronomers don't know something, they tend to say dark energy.
Even though scientists are baffled, they know this thing called dark energy makes up 70% of what's out there in the cosmos. It's stronger than gravity, and may eventually be stronger than the forces that hold atoms together.
My body is held together by the electromagnetism in my atoms. But what if the expansion of space increases and accelerates, and it even overcomes those forces? Astronomers are calling that the Big Rip. And although we don't know this will happen, it's a possibility that eventually the expansion will get strong enough to rip apart atoms, to rip apart our very bodies. Even matter will fly apart.
One way to wrap our brains around the expanding universe and the Big Bang is to use an analogy. For instance, tennis balls on a piece of elastic. Here, each tennis ball represents a galaxy. So this one could be our own Milky Way galaxy. And the elastic is space itself. Now, since we know the universe is expanding, it's like taking this elastic and stretching it. Now, as the elastic expands, the galaxies start to spread out and get more and more remote from one another. So our simple model of the universe with tennis balls and elastic literally breaks down if we try to apply it to one ruled by dark energy. Because if we're trying to show a universe in which the rate of expansion between the galaxies is actually accelerating over time, our elastic would have to stretch infinitely far, and we would have to run away from each other infinitely fast. Now, we can't do that with a simple model. And that, in a way, is an example of just how bizarre a dark energy-dominated universe could be.
And initially, the universe was thought to be static and not expanding. As I said earlier about this, Einstein statics universe of constant positive and curvatures. And here is, in the, as we know, this Edwin Hubble and the American astronomer Edwin Hubble made the observation in 1925 and was the first to prove the universe is expanding. He proved that there is a direct relationship between the speed of distant galaxy and their distance from the Earth. And as we are familiar about the Hubble's law, and Edwin Hubble, and here is his telescope, that's MT Wilson 100-inch telescope. And as Hubble's law explained about the expanding universe, and Edwin Hubble determined that the greatest distance, the distance of the uh, of a galaxy is from the Earth, the greater the redshift of the light is emitted, and therefore the greater the speed. And here's the simple relationship between the Hubble's distance and which we use, and where Yacho is the Hubble constant, and the current value of the Hubble constant is about 70 kilometer, but about the, according to data just now, it is 73.2 something here of kilometer per second mpc. The Hubble constant is 73.4, and as we know, the Doppler's effect also explains the universe, and that's about the redshift. And the evidence from the Doppler effect is about the blue shift, red shift, and Edwin Hubble showed that there is a red shift of the star spectrum, which so the galaxy are moving away from us, and it can prove that expanding the universe, about the expanding universe, and how the red shift so this universe is expanding like original wavelength. And here is the original cosmological redshift, and here is the original wavelength where space distance galaxy is contrast. And here is this where it is expanding like space and distance galaxy, and from the Earth they are going far away from the Earth according to the time, increasing enough time. In the expanding universe, if everything is moving from away from us, then in the past everything was a lot closer maybe, and then density was greater and pressure was greater and temperature was higher. And so after this getting the balance, we are able to live here because of the balanced temperature and density pressure. And sometime in the past it was very small and hot, and it is believed that the universe was just contrast in one way, and expanding day by day with according to the time. And at conclusion, there should be the residual radiation left over from his dense hot periods. And here's thing, and here's the expanding universe. And that's all about I prepare here for today about the expanding universe, and I have some introduction and this theory about the expanding universe to present here. Thank you.
Wow, Deepti, I'm really impressed.
Yeah,
I'm really impressed. I gave Deepti something less than 24 hours to put that presentation together.
Wow.
So I think she did a very good job. So
Very
that's
nice.
great. That's great. Okay. Our Molly had mentioned that she has Mars in the
All right.
telescope at this point. Let's take a peek at
do
Mars.
indeedy. Give me just a second here. There we go.
Oh.
So this is my my monochrome camera is on here, so it's just a black and white image, but we do have Mars here. Sorry, my phone's making noises. And I'm gonna go pull up my little map here real quick to see what feature we are looking at the present moment. But you can see with the different colors on the surface, kind of some of the larger surface features of Mars. Oh my goodness. Let's see. Yeah, so we're not looking at the Mariner Valley side at the present moment, but there's a large area of kind of darker red geological feature here, as opposed to the lighter red, kind of less mountainous area up toward the top. If I had the color camera on there and I processed an image of it, you would be able to see the small white spot that is the South Pole. However, I'm a little bit short of focal length in this view, so you can't quite see it.
Great, Molly.
Nice. Thank you. Thank you.
Thank you.
There's a dust storm if I'm not if I'm right. Are you on Mars right now?
Okay. All right.
One was
So I
forming.
think that I
Oh,
think
go ahead.
I'm sorry. Go ahead.
Oh,
Go ahead.
yeah, I think I heard that one was forming, but it doesn't look like it's gotten too bad yet. Not as
No.
bad as during the 2018 opposition, at least.
Yeah. All right. Thank you.
So we're going to talk with Chuck Allen, the Astronomical League. The Astronomical League is the sponsor of the Explorer Alliance's door prizes during the Global Star Party. And as is tradition, the League reads the answers from the last Global Star Party and then asks the questions for this Global Star Party. The answers are to be emailed, not sent in chat, okay, because they don't count. But you would answer them at Explorer Alliance. I'm going to put it in chat here at explorescientific.com. And the way that it works is you would submit your answers. Okay, all the correct answers will land in the email, and we will at random pick one of those correct answers out of the group of correct. Okay, you will then have a chance to win one of the door prizes from our prize partners, which would include the Mark Slade Remote Observatory, Gary Palmer Astronomy, and the Vacuum of Space astronomy gifts, and Explore Scientific as well. So just to keep it fun, we always have the Astronomical League choose the questions. They decide who they verify the winner, and then we let those winners know by email. And so, Chuck, are you with us? Hello, Chuck. I can see him there.
He's in the black hole.
He's in a black hole.
Yeah.
Well, we're going to come back to Chuck then, okay? We'll do this later.
Currently being spaghettified.
Okay.
Now I'm hungry for dinner.
All right. Okay. Since Chuck is apparently not there or incapacitated or something, hopefully not incapacitated, we are going to go jump to Mike Overacker. Mike is new to the Global Star Party, and I thought that we'd have him come on. Mike and I were talking earlier today, and he's coming on as an Explorer Alliance ambassador. So I thought, well, gosh, we should have him introduced here on Global Star Party. And we started talking about different things that he's passionate about. Of course, he loves all things astronomy. He loves astronomy outreach activities that he does, of which there are many. But he loves meteorites too. He's also a musician. You can see a couple of guitars behind him. And so, Mike, I'm going to give you the stage here.
I'm hoping that my microphone's working. Is it working?
It's working.
Okay.
Your video's working. Your microphone's working.
What are the odds?
It's all working. Yep. Thanks for coming on.
I'm Mike Overacker. I've been in astronomy outreach since about 2004 just before I retired from the fire department. I was a firefighter for 24 years and hazardous materials technician actually specialist for about 15 years or so. Anyways, astronomy is great, but on rainy nights, there's good to get something else going. So I got into meteorites. I am a member of the International Meteorite Collector Association. And if you see my collection, you know that I'm definitely a collector. And two main types of meteorites. There's chondrites and there's octahedrites. And chondrites are basically meteorites that are conglomerations of collisions of other bodies, and they form this basically a conglomerate and a crush of small pieces, And these small pieces are usually circular, and they're called chondrules. And this is I'm going to try to get this up here so people can see. This is a chondrite.
It's a little bit out of oh, there we go. Now we got focus. So those shiny pieces in there, I guess, are metallic.
Right. Those are iron, nickel iron, and the rest of it is a basically a crush of dust and grains of sand and so on and so forth. Meteoric.
It's a pretty big meteor.
Yeah, this one is.
Meteorite.
This one's about 5 pounds. It's
Yeah.
NWA 4488, and NWA means Northwest Africa. That's where it was found. And these chondrites are rather common. About 90% of the meteors that fall onto the Earth's surface are chondrites. About a ton a day land on the Earth. And but you also have to realize that, you know, if a ton a day falls onto the Earth is 75% water. So chances are good 1,500 pounds splashes in the ocean, and we never get to see it. And chondrites are rather common. Let's see, I've got several of them around here. Here's another one. I have to do this and put it in front of my face so the camera will.
There you go.
Okay, this one is called a gold basin.
Oh, wow.
This one comes from Arizona. And you can sort of see on this side, you see that dark patch?
Yeah.
The dark patch is called fusion crust. And then you can see the inside of it, kind of lighter colored, made up of small pieces of debris. That fusion crust is what is one of the ways that we tell a meteorite is landed. It's where it burned as it came into the atmosphere. And people automatically assume that meteorites fall all the way to the ground. Well, they all fall all the way to the ground, but I mean that they zoom in all the way to the ground. And that's not necessarily true. When you see a shooting star, most people assume that whenever it goes out, it burnt up in the sky. And that's not necessarily true either. As they come in, they slow down from friction. That's why they glow and have that plasma around them that burns the surface. And they slow down to the point where they're no longer glowing. They can still be 90, 100,000 feet into the air, and they go into something called dark fall. At that time, they're just falling to the earth at standard falling speeds. And they land on the earth, and people assume that they're hot. And for the most part, if you happen to see one and land, and you walk over there and pick it up, it's going to be very, very cold, because it's been in the upper atmosphere, and before that it was in space. So the short amount of heat as it comes in is not enough to warm the entire body for the most part. Okay, and those are chondrites, and there's several more of them here. This is a Wolf Creek. This one's from Australia. And you can see the surface is kind of rough, and this is all fusion crust on it. There's no look inside of this one. This is what's called an individual. In other words, it's a complete stone. And the one thing that really is a good indicator of a meteorite, people ask, how can you tell if it's a meteorite? First of all, it's magnetic, because it usually has some amount of iron in it, although not always. But another way is this way. This is a Campo de Suelo. And look at these undulations. Let me get behind it there.
There you go. There you go.
The camera wants to focus on my face.
Yeah.
I don't know why. It's kind of, but this is, gosh, you wouldn't believe how heavy this is to hold down here. Those are called regmaglyphs. And what they are is as the stone comes in to the Earth's atmosphere, it's usually tumbling. And as it tumbles, it creates these eddies of plasma across the surface. And these are very, very violent eddies. and they scoop the material out as it melts this body as it's coming into to the Earth's atmosphere, and it creates these thumbprints or rigmoglyphs. And it's one of the ways that you can really tell what it is. But sometimes, let me get this one up. This is really rare. This is the same fall as that last one.
Okay.
But if you look at it, there are very, very few rigmoglyphs. This is oriented. This one basically came in and flew in rather than tumble. And as it flies in, it creates basically a wing shape.
Oh, wow.
And that's pretty much the way it came in.
Yeah.
And you do not find them like this very often. And another neat thing about this, I show this to kindergartners all the time because first of all, they can handle any of my meteorites. I'm not persnickety about that. But this one here, I wish we had smell-o-vision. This is 6,000 years old, and it still smells burned. It's the most amazing thing. The other Campo doesn't smell burned, but this one, it still smells like it just fell. It's 6,000 years sitting on the Earth's surface, and it still smells. It's amazing.
Huh.
And one of the really, really cool things about octahedrites, which I've been showing you here, which are iron meteorites, is this pattern. It only happens in meteorites, iron meteorites, and it's what happens whenever iron and nickel crystallize and cool over millions of years. It allows this iron and nickel to form into crystals. It allows them to line up. But it only can do that over millions of years. We cannot reproduce that process here on Earth. And it creates this thing here.
Oh, yeah.
Called a Widmanstätten pattern. And this is only in meteorites, only in iron meteorites. And this one is Muonianalusta. This one came from the Nordic region. Let's see. I'm not sure exactly where. I can't even read here. Sweden. It came from Sweden. But they don't necessarily show that same thing. Here's a Dornino. And this is also.
Oh, wow. That polished almost a mirror finish.
Polished and shiny it is.
Yeah.
And it shows no Widmanstätten pattern at all. And just a couple more really cool ones, and I'll move on. We already talked about stony meteorites, and we talked about iron meteorites, and there's actually one in between that actually Scott and I discussed, and they're called pallasites or stony irons. Really creative here. And this is a brahine. Oh, wait, let me get. Is it focusing on it?
Not yet.
No, not quite.
It's trying. It's trying.
Let's try a Seracho here. This is bigger.
Okay, that might work. Yeah. Oh, yeah. Look at that.
So cool.
Yeah.
These are that is metal, and amongst the metal is are crystals of olivine, and those olivine crystals are actually peridot, meteoric peridot. Peridot is you can get on the Earth. And it's found all over the place around here, actually. But meteoric peridot is quite a bit purer. And I'm going to show you, you don't normally see them. This is a peridot crystal.
Wow.
They don't normally get this big.
That nugget is a crystal.
That is one peridot crystal. Yeah, this could actually be cut into probably several gems. But normally you'll find them, they're about 1/4 of an inch to maybe 1/2 of an inch in size. This is rather large. And just for kicks. And I'm only going to be able to hold this from.
Wow.
It
This
looks like
is
a crocodile head or
Wow.
something.
this
Tyrannosaurus Rex.
Yeah, T-Rex head.
just shy of 14 pounds. I'm putting that down. That one is that's a Nantan
right there.
It's from Nantan province in China. That's actually an observed fall back in the 1400s, and you can usually find them, but you don't normally find them that big.
Right.
But that's just kind of a
That's very cool. That's very cool. No one else has ever given a dissertation on meteorites on our global star
Great.
planet before.
That's great. Thank you.
You're welcome.
It was awesome. It was awesome. We are going to take a 10-minute break, and when we come back, Chuck Allen is now ready and to do the door prizes. But we'll take a 10-minute break and then come back to him, and then we're coming back to Norman, the one and only Norman Fulham. And so, yeah, and so yeah.
It's a good thing. It's a good thing.
It's a good thing. So thank you. We'll be back in just a few minutes here. So.
Are we off?
Well, the mics are still hot.
Okay.
But we're at a 10-minute break.
Sorry about that.
Oh, no problem. No problem.
Last minute correction.
It happens.
Well, I should have looked at them before. These were the ones given to me by someone else.
We'll punish them at the next Alcon.
Yes.
Okay, I'll be right back, guys. I'm going to make a little stop, and I will be back with you. Well, we are back, and we have Chuck from the Astronomical League, and he is here to read off the questions from the last Global Star Party and to read off the questions for this Global Star Party. Now, the way that this works, as I mentioned before, you will answer these questions in email, and I'll go ahead and put the email down in there again in chat. It's Explore Alliance at explorescientific.com. And when you answer these questions, all the correct answers will be put kind of in a virtual pile, and we will at random have one selected, okay? The Astronomical League officers create these questions, and so we're proud to have the League working with us on this. Chuck Allen has been on our program several times, and he always comes up with some very good questions. I think some have been some stumpers too. So, the League is, the Astronomical League is nearing its 75th anniversary, which I think happens next year. They have something like 18,000 members and over 300 clubs, and their reach is now going international. They are working with individuals and I think organizations all over the world. So it's a venerable organization, mostly run by volunteers. And aside from these, their presence here at at Global Star Party, they have events that are held around the country. They have a national event called the Alcon, which I've been to several of these, and that's where a lot of the League's presentations of the awards go out, like the National Young Astronomers Award, the Leslie Peltier Award, the Jack Horkheimer Award. All of those are for youth, but they have other awards as well for web design and I think for scientific drawing at the eyepiece and all of these things. So it's the tendrils of the League go everywhere, and they're a great organization, and if you don't belong to them, you should consider joining them now. So you should, when you get a chance, go to astroleague.org, and you can find out more about them. Chuck, where do we start here? Let's do the, I guess the last Global Star Party's answers.
Sure. First of all, good evening, everybody. Sorry I wasn't here a little while ago. We had a little error on one of the slides that had to be corrected, and so we're ready to go now. Can I share a screen now, Scott?
You sure can.
All right. All right. First of all, just to, hang on just a second. How's that look?
Looks fine.
Okay.
Nice.
We always We always like to give a little solar warning to everybody before door prizes are handed out. And it's just a good thing to review with astronomers, amateur astronomers around the world, especially those who are starting into astronomy. As I've often said to others, accidentally seeing the sun through a telescope can permanently blind you about 500 times faster than you can react. Your brain can react to seeing something too bright. So it's a mistake you cannot afford to make at all, ever. Never observe the sun without professionally made solar filters that include energy rejection filters at the front end of the telescope that are securely mounted. They used to sell telescopes where they have these little welder's glass eyepieces that go on the eyepiece. No, heat builds up behind those, tremendous heat builds up behind those and can crack them. Never leave a telescope or binoculars, excuse me, unattended in daytime where young people might accidentally try to acquire the sun with them. If you're using eclipse glasses, make sure they comply with ISO standards. The Astronomical League can help you find reliable sources for eclipse glasses. And cap your finder scope. If you're showing people the sun through a telescope using proper filters, sometimes we forget to cap the finder and people end up with a hot image of the sun projected on their cheek as they observe. And there are people in local astronomy clubs who are very skilled at solar observing, and you can certainly consult with them.
I want to also mention a video that Scott did with eclipse glasses. What happens to eclipse glasses if you use them to look through a scope at the sun?
Yeah,
it's very bad. That's a video you might want to link.
Now, this to Jerry's point there, the reason why I made the video is we actually had an experienced amateur astronomer call us and ask us, is it okay if he looks in his eyepiece wearing eclipse glasses? And you'll see from the video, which now I think it's the highest viewed video that we have, but it instantaneously burns through the eclipse glass filter. Okay, so you definitely, that part about over the lens filtration is very important.
That's a classic example of something that is easily omitted from these warnings. Perhaps we ought to add it. It never even occurred to me somebody would try that. Okay, the first question, these were questions posed by Carol Orge, our president, during the last session. And the question was, in what years was the Leonid meteor shower first discovered? And who made the discovery? And the answer was that it was first recorded in 902 AD. And it was recorded by unnamed Greek, Italian, and Chinese astronomers. So that correct answer was given by Mark Hilton, and he is our winner on question 1 from those questions. Question 2 is, what are the 2 brightest globular clusters in the sky? And the answer to that question is Omega Centauri and 47 Tucani. Those of us in the southern United States have a shot at Omega Centauri, 47 Tucani. You're going to need a trip south, but they are quite bright objects. Michaela Jennings is our winner on question number 2. And the third and final question, what are Trojan asteroids? And they are small rocky bodies, asteroids, that share the orbits of larger bodies like planets or moons, remaining at a gravitationally stable position, either 60 degrees ahead or behind the main body. The most famous, of course, are the Trojan asteroids that precede and follow Jupiter in its orbit. And the correct answer to this question was given by Andrew Corkill.
Wow.
Okay, so our questions for tonight. First one, what is the 3rd most massive planet in the solar system?
Okay. 3rd most massive.
And question number 2. This first magnitude star in our sky is actually a 6-star system. Which star is it? And finally, before I get to the third question, I'd like to show you one of my prized possessions. This is a 1921 Norton Star Atlas.
Oh, wow.
And in the era of 1921, the constellation boundaries were drawn very roughly. They were drawn in curves, as you see in this Norton Star Atlas from 1921. It was not until 1930 that Eugene Delporte actually drew up constellation boundaries that then comported with lines of right ascension and declination. And the IAU, the International Astronomical Union, which is the international body of professional astronomy, adopted those boundaries for the 88 constellations in 1930. And so now the boundaries look squared off like this. And the of course, what you will notice up here at the top is the boundaries are no longer parallel to the lines of right ascension and declination because, of course, of precession of the Earth's axis. And that will become increasingly apparent as time passes. So relating to these squared off boundaries, it is now possible to determine the number of square degrees in each constellation. And so what is the largest constellation in the sky by area? That's our third question. And Scott, that will do it for tonight.
Well,
thank you very much.
That wraps it up. That's awesome. That's awesome.
Okay, I will stop sharing.
Okay.
There we go. Thank you.
I thought that the, I never knew that they had constellation boundaries that were just kind of curvy and, swoopy. I had never seen, you certainly have seen the older, like Uranometria and the older Bayer type of star maps where they have the mythological figures drawn in them, but with no constellation boundaries. But I'd never seen them with the swoopy constellation boundaries. So that's very interesting. And I've seen other Norton Star Atlases too. So that's almost like a whole lecture in itself is about Norton. So we'll have to get into that. That's really cool. That's really cool. Well, our next speaker here is Norman Fulham, and Norman has been on our program several times. He took us through a tour of his shop, Fulham Optique. Is it Optique Fulham is what it is, right?
Optique Fulham, yes.
Optique Fulham. And it was absolutely fascinating.
Going on to telescope, not my Fulham well.
For me, I mean, having been in telescope manufacturing for a while, to actually know somebody who's made their own coating chamber, not just for a little optic, but something like 65 or 70 inches in diameter, okay? Their own giant polishing machine, making their own giant telescopes, as well as making these works of art that he carves out of wood that are also telescopes. And he's an artisan. He's an amazing engineer. He is someone that has, he breaks, all boundaries as far as what astronomy and amateur astronomy is all about. I really admire this guy. I think he's one of the great telescope makers of the world. And so I'm glad to have you back on.
Well, my pleasure.
And he is an incredible musician too. Almost every time he puts like a knot in my throat. Almost every time when he plays. So, anyway, I'm going to turn it over to you, Norman. Thank you.
Scott. Okay. I don't know if I think that some of you guys saw some of my previous presentation, and one of my first one was I was relating the most of my lifespan, and my presentation tonight is going to be a PowerPoint presentation that I did many years ago when I first started. It spans from, let's say, 1995 to about 2010. So the real memory lane for me at the beginning of the wooden telescope making that my business started that way with the wooden telescope and optics. And Chuck saw the second presentation this week from 2010 to today. So maybe next time I will present that one. But let's start with the beginning. I translate all the headers of the presentation today. It was in French originally, so I translated in English for you guys. And if you find it too long, it's quite a lot of pictures and a lot of stuff in that presentation. If you find it too long, just let me know. I will cut it off. I will shut it off before. And I'm just gonna share my screen here. How did that go here? This share this. There we go. Beginning of the presentation. From the beginning. There we go. So does everybody sees everything? Yeah. Yeah.
Yes.
Yeah.
Okay. So telescope Namafalam, what an adventure, and it's been an adventure, let me tell you. So let's start with my first telescope, Bertha 1. That was her name.
Oh.
A 12.5-inch f7.1 telescope. I did the optics first, and took about 9 months to do the optics, and then I did the structure of the telescope. That's my oldest son. Then it was 60. He was about 60 years old then. So all plywood, truss tube, very basic type of telescope that you learn to make if you read the books of how to make telescopes. So I was very proud of that telescope. I had great image of the the planets, pretty much all the deep sky too. So this is the first telescope that I built, Bertha number 1. Then came number 2, the first wood telescope that I built. The reason why I built it out of wood is that the house we just had bought there in Hudson near Montreal, the old owner of the house was a woodworker, and he had left a lot of wood in the shed. So I said, why not build a telescope out of wood, a tube with olive wood? That's what it was. This one is made of maple. It was a 7-inch f4.5 that I built as a second telescope. I had convinced my son that he needed a telescope also. So that was number 2. After that, well, in those years, I was alone in Hudson with friends, and there was no astronomy group in the area, so I decided to found my own group, so the Lunatics of Hudson. And on the left is the first logo that I designed for the club, and then people told me, said, well, maybe you would need a professional, someone to draw you a nice logo of the club. So the Hudson Lunatics. The club doesn't exist anymore in the area. It was replaced by a larger group in Valleyfield, in Montreal, also in Dorval. But there's a few people that started the club with me that's still together. So after that, I will show you. Please be careful here. It's very stressful area here.
Oh my gosh.
It's my very, very small basement where it all started. Well, I built my first telescope. My basement, just a part of the house underneath had a floor, and it's very small, about 10 feet by 11 feet. That's the size of my basement. The rest is a crawling space, so I couldn't use it. So in this area, you have my first Meromatic machine you see on the bottom right here, tube of telescope hanging from the ceiling to dry, and a abrasive on the ground here. So I had to do what I had. I mean, I didn't have a choice if I wanted to build telescope, I had to use the space that I had. Sure. So, of course, it was a dust-free environment. You see at the back here,
there was no room for dust. There was no room for dust in that place.
That's true. When people were coming over, friends were coming over to see what I was working on. Especially Pierre Tourné is about 6'4", and you had to bend because his head was going in between the two, 2 feet in the basement. You couldn't believe I could work in that area, in this environment.
Wow. You made some
And of course,
beautiful telescopes down there.
lots of room, lots of room. But anyway, that's where it started. That's where I built my first telescopes. And after a while, well, I had to do a logo for the company. And if you know, people that know my telescope, the altitude bearings of all my wooden telescope is the man in the moon. So I hand draw the logo of the company here to start with, to inspire me on how to do the altitude bearing.
Wow. What year is this, Norman?
Around 95, 96, 1995, 96. So here you see Bertha number 2, because when I started to do the wooden telescopes, I took my first telescope. I took the mirror out and I said, well, I'm going to try to build a better and nicer structure to the telescope. So that's what I did. Made of this one, Coco Bolo, in 3 sections because of very long focal length, f7.1, and I got a little crazy on the design. And you see here my first wooden telescope, like I showed you earlier, that I had built, made of maple, the 7-inch f4.5. So at that point, I was starting really to think to start a business. With Bertha too. When I presented that telescope at star parties and at Stellafane, I won first place award with this baby here, and different places. Yeah, I also had built a manual equatorial platform here with a cable and that you can move manually, and also the focuser also was a handheld manette that you can do the focus without touching the telescope. So that's Bertha number 2.
That's very cool.
Telescope number 3 at Stellafane. I had won first place award again for craftsmanship. So you see me here at the presentation below the pink clubhouse. And when they awarded the first prize award, there was a big picture of the telescope there on the big screen there on site. So I kind of got hooked at Stellafane after a while. So this is Al Nagler here at Stellafane. You meet a lot kind of people over there that you normally would meet. On the left corner, lower left picture here, this is the first wooden telescope that I didn't present at Stellafane. If you remember the story, I was working that weekend and the club of Valleyfield brought the telescope to Stellafane to present it, and this is my friend Walter here that passed away not too long ago, unfortunately, that presented the telescope for me there, and then called me up on Saturday night, said, Norm, you've won the first place award, yay! So, on the right, bottom right, is another year. I presented the two different telescopes. After that, what do I have here? Okay, in my area in Hudson, not anymore, but in those years they were doing artisan tours of all the artists living in the area. It could be a painter, could have been anyone to do arts, and I was a telescope maker, so I was part of the tour. So I was showing my work in my backyard to people coming around, and it was a very, very popular event. You can see here my first Foucault tester here with the little bench, all the abrasive here, showing people how I was doing the grinding. This is my Mirror-O-Matic here, the background, different telescope on display. And then I was installing telescope in my backyard into the gardens. So there's a nice 12.5-inch f5 here that I built for my friend Pierre. There's another one here, a 10-inch it was a nice setup, a nice setting for the telescope, the type of telescope that I was building then, to have them in flower in gardens. People really, really enjoyed it.
Yeah. I'll remind the audience that Norman is self-taught on all of
Yeah.
his telescope building, all of his mirror making, everything.
Yeah, woodwork, mirror making. Yeah, I read I read a lot books and then how to
you still got to do it.
all this and how to do how to carve, and I was very lucky that my good friend Pierre I was telling you about earlier, his dad was a wood carver. He was carving a lot of wood, and when he passed away, his wife had kept all his tool, all his wood chisel, and at one point Pierre on a Christmas day gave me a present that all his father's tool and carving tool, he gave them to me as a Christmas present, saying the only reason that you're going to be able to use them is if you use them. I give them to you only if you're going to use them. So I put them to work.
Yeah, they're beautiful. You've done it.
There's another one, beautiful view of a telescope in the garden. And of course, it's hard work.
Yes.
You have to rest at some point,
That's right.
Okay, and then different awards over the years. I got 7 first place awards at Stellafane, plus multiple other one, second and third place, and also the CAFTA competition in Quebec. It's also like a small Stellafane, but in Canada. I have many awards over there. And also there's an award called Ovation Awards in my area for the business, the newest business and the type of business I was making. I got a first place award for Ovation competition. Okay. New workshop in 2007. So in 2007, I was able to have a workshop, get out of my basement. So it took about 8 years. So I moved into about a 800 square feet shop. And then after that, I had it expanded a little more. So you see, I had to build whatever working area that I needed. On the bottom left here, I had to make a wall to all the woodwork on one side and the optics on the other side, so the dust doesn't get into onto my grinding machine.
Mm-hmm.
So yeah, I was a very happy man to get out of my basement. Let me tell you.
Right.
And
you finally had enough room for dust now.
Yeah, so I was on a building mode. So I built all my work tables. I built all my tunnel for the Foucault testing. At that point, I had 3 grinding machine built. I had to do the cover, all the plastic cover, so the dust doesn't fall on the mirrors. And this is the area for the woodwork on the left, bottom right. Sorry. After that, official opening 2007. So I was ready to open to work and produce telescope at my new shop. Those are Pierre, my good friend, my future employees. I was telling them.
Right.
Okay, now the real work, fun. Well, it's not work; it's fun. So I could really start to produce more and more telescope at the same time. So it was very fun. So you can see there on the left the man in the moon carving altitude bearing. Mm-hmm. So that's where it was done. That's where it's done. The first large 36-inch sandwich mirror. The blank wasn't mine. Another guy in Canada was producing regular glass blanks for sandwich. He was doing just for fun. And I tried this material for about 2 mirrors. Where the first 36 was available, the rest is will show you the second story. It wasn't that great. So the first 36-inch mirror I did was in that shop. I had built the grinding machine before I moved in the shop. You will see here. I built a lot of grits for, of course, for the 36-inch. So this is the first grinding period for that mirror, but it wasn't even the shop. It was in my friend's Pierre basement. I had built the machine there because I didn't have room in my basement to build it. So I had a 22 inches grinding tool that I do all my grinding tools also. So they're made of glass, cut in square and epoxied on a aluminum base. So this is the grinding tool that I use for that 36-inch mirror. And ta-da, it's working. We started a big adventure of big mirror here. So after that, polishing is done. I moved everything in my new shop. So I did the polishing in the new shop. And it was a success for that mirror. And this one is in a telescope near Quebec City to the group Petite Rivière du Nord. They build their own structure for that telescope, but they have my optics in it. But to do that mirror, I needed a place to, well, first I'm going to show you the testing of that mirror, the Ronchi test, and a little bit of the Foucault testing that I did for that mirror. And just to show people that there's no print through in my mirror. Many opticians say that if you have a sandwich mirror with pillars in between the two plates, you will end up with print through on the surface and the figure. This is a proof that it doesn't happen on mine.
Right.
I developed a technique to make them. So the coating, in those days, I didn't have the coating machine. So I was doing my coating in Pittsburgh, a company called Fleabag. So I was driving my optics down to Pennsylvania, do the coating, stay in the hotel for a few days, and then bring back the mirror at the shop. So they were very well equipped for coating. The original company is not for mirror coating, but they were giving me the service because I asked for it. Mm-hmm. They were doing all kind of automotive coating. They had dozens of vacuum chambers, and when they closed down, I tried to buy them. One of them, they will never sell it to me. They move all their machine back to Germany. So that's why I had to build my own. So the first mirror was coated there, and it was done. You can see here the first mirror was coated over there. And there we go, in the box, in the crate, and delivered to my customer in northern Quebec. There it is. So I was very, very happy. The first result, a very big, large mirror that I made.
Yeah.
Yeah. So at that time, I started to go to NEAF, Northeast Astronomy Forum. So Alan Treno was the organizer then for the NEAF forum, and so unfortunately he passed away a couple of years ago, but he's the one that invited me over for the first time. He had to see my wooden telescope at Stellafane, and he said, Norm, you should come to NEAF and then present your telescopes. So I went there in 2007, my first time. The NEAF, this is the NEAF overview, the floor over there. I'm sure everyone present here, or most of the people saw NEAF or went to NEAF in the past. It's a very, very inspiring place for amateur astronomer. And this is my kiosk. I don't know, you say a booth in English, sorry. So this is my first booth at NEAF, the first NEAF that I did there. I had brought a 12.5 inch, a few 6 inches, 8 inch. And like I was mentioning on my previous presentation that on my first NEAF, I had Mr. Marcus Lutz that bought my first wooden telescope there on site before the opening of NEAF. So he was very excited of his small 6 inch telescope that I had built. So he bought it right on the spot before the opening. And then NEAF 2008, same thing, packed the van. And you should see the face of custom boy, the agent at the custom asking me where I'm going with what. And I opened the back door and said, they looked at that and said, what the heck is that? Tried to explain to them what it was. They wouldn't understand. They wouldn't believe. So it happened once that I had to empty the entire truck, show them, assemble one of the telescope, and then show them what it was. Oh, so just that is quite an experience already in itself. And then, of course, that second year, I had a very nice booth. With this is a 16-inch f4.5 that I had brought over there. And then after that, 2009, I had brought some more telescopes. So I've been to NIF many years in a row. It was a very good platform for my work when I started.
Yeah.
And then the one I was telling you about, CAFTA in Quebec, le concours annuel de fabricants de télescopes amateurs. So the Canadian Stellophane, it's not as popular, but it was great to see all the Canadian astronomy amateur over there.
Yes.
So I've always been there. And I think David Levy came and did a talk there at the CAFTA one year. And of course, the Winter Star Party in Florida. I've been there many times. It's a great place to observe in the wintertime without minus 20 degrees.
Yes.
So again, in my previous presentation, I was telling you about Marcus Ludus that bought a telescope again from me on site after seeing the Thor's Helmet nebula with my telescope. He really liked my telescope, so he bought it right there on site. This is my booth that I had over there. And good deals to be made at Winter Star Party. Hopefully they will happen again next year or the year after. It's one of my favorite places to go observe at the same time and meet people, and great weekend, great week to be on site, meet a lot of great people, good observing too. This is the first place that I saw the Omega Centauri nebula. I was so blown away with the view, with the 16-inch that I showed you. That was magnificent. After that, and then I went to Paris also, did some promo in Europe. So I brought a couple telescopes at Rencontre Ciel et Espace. It's a biannual, like a NIF exhibition in France. And I was invited by an astronomy store called Galileo in those years. So I was part of their presentation there. So I was very proud to be in France and show my stuff over there. I had brought some very nice telescope that I sold on site too. So I was very happy for that. And also I went to deliver a few telescopes in Italy. One of my customer here, Fabio, he's got 3 of my telescope also. He likes my work.
Wow.
This is a 12.
Everybody likes your work.
Well, there's liking my work and buying my work. There's two things. It's, you see, the reason why I, right now, just a little parenthèse, now I had to kind of change my my vision to diversify my product, because if I would have stayed just wooden telescope like that, I wouldn't be in business anymore. Because I mean, you buy a 12.5-inch telescope for maybe $3,000-4,000 now, and then this one was way much bigger, higher price than that, and so it's not everyone's. I hope the compressor, you don't hear the compressor too much, I hope.
It's okay. We can hear you over it.
Okay, because I have no control on that. It's my air compressor in the shop. It starts once it wants to.
Right.
It will stop very soon. All right, let's keep going here. Big project for Orion. You probably knew my Orion monster dump project that I had concluded with Orion. And there's the story behind that. I will tell you a little bit of the story of that. So Orion contacted me to make a big telescope line, and I accepted with my Technofusion mirror, not a Technofusion, but a sandwich mirror that I had the guy produce from me. So this is the structure that I built in my small shop then. Got the altitude bearing, the ground board, this is the rocker, and And when I was building that telescope, of course, my friend came over, the inspectors, to tell me if it was okay. I always have friends coming over looking at my work. And there's the mirror box for that 36-inch. I'm trying to go quicker here because I know you guys want to keep moving. And because my shop was the ceiling of the shop, my shop was too low, I had to go work some parts at my machinist shop to be able to assemble some parts because I didn't have room in my shop. And this is the mirror box with the altitude bearing assembled together. And then I brought this part of the shop just to be able to do the paint work on it. There's the 27 points floating cell for the mirror. Of course, it was all aluminum for that size telescope. I wouldn't work wooden parts. Would be too heavy first, and then too wobbly, not strong enough. So that's why I decided to do all aluminum. It was my first big project for a large telescope. And this is the cage, and it wasn't a folded Newtonian like you saw in my previous presentation. This is a regular, so the very long telescope. Well, you saw that telescope, Scott, at the Starfest in Toronto, right? You remember?
I remember.
It was a nice telescope. And what happened though, I had the inspector again. When the telescope was completed, the mirror was finished, but what happened is I had tragedy. This is the primary mirror. When I brought the mirror to Fleabag in Pennsylvania to have it coated, because the mirror itself was made of regular glass, not Pyrex. Okay. The first mirror they had coated in a very, very large vacuum chamber, so the element that vaporized the aluminum was very far from the mirror, so the radiation wasn't affecting as much the glass itself. But for that mirror, they used a smaller vacuum chamber, so the elements were closer to the glass, and it warmed up the glass a little more. And because it was regular glass, it just shattered. Yeah, wow. And that was 3 weeks before going to NIF with the telescope to present the telescopes.
Oh.
Yeah, yeah. So I had a very weird conversation on the phone with the Kevin over there when that happened. So yeah, here it is. Is that the leftover of the mirror in the vacuum chamber?
Yeah.
I still have this part here in my closet here in my shop, just a reminder.
That's good.
But that didn't stop me. I borrowed the mirror, the first mirror that I had made out of glass, to my friend in Quebec. I asked him if I could borrow his mirror to put in the telescope to do the presentation at NIF. The focal length wasn't the same, so we couldn't use it, but at least there was a mirror in the structure, and we could present the telescope at NIF.
Right.
That's what we did. So I brought the telescope at NIF. There it is on the floor over there.
I remember.
So we could show the telescope. So there it is. So when I came back to Quebec with the telescope, I had to make another mirror. And the second mirror I did with my technology that I was done in my workshop after 2010, the Technofusion, which is the subject of my next presentation, maybe that I will do for you guys if you want, about how I developed the Technofusion and how I did those first mirrors. Here, this is my new shop. When I moved in here in 2010, so I had to bring some of my working bench, working table, some of the telescope I already had started, and hey, I had an office. That was something.
That's right.
A place to work and design and draw my telescope. And I was very, very, very happy when I moved in. The grand opening was in 2010. So that was an empty area that about 3 times the size of what I was having at my first shop. And there's a door right there. After about 3 years, I had to expand on the other side too to up to 3,500 square feet of in my shop. So maybe next presentation will be that shop.
Yeah.
And thank you very much for listening to me.
Norman, thank you so much. Thank you. Okay, that's great. Okay, so I guess at this point we will see what I know. Molly has still got some clear skies. So Molly, what do you want to show us?
So I've got 2 things to show. First, the Andromeda Galaxy in color, and then the Helix Nebula in monochrome hydrogen alpha. So let me. The moon is pretty bright tonight. As we saw earlier, it's waxing gibbous. So I have a lot of background. So Andromeda Galaxy ended up looking more or less just like a blob, like it does with the eyepiece. But here we have the core of the Andromeda Galaxy, and if I were to process this a bit to remove the background, we'd get a lot more of the dust lanes and whatnot. But yeah, this is a live view of M31. I'm doing a live stack in.
Nice.
Bring out, you can see the dust lanes a little bit there.
Beautiful.
Let me switch machines real quick. I have two laptops out back that I've got one running one rig and one running the other rig, and I can remote into both of them, so I don't have to go outside really ever to do anything with them.
Oh, I see.
Yeah.
Nice.
Oh dear, what happened to my photo here?
So you have your own mission control, like in your living room.
I had an image. I don't know what happened to it. Oh dear. And let me turn off the live stack and see what's going on here. Okay, well, I will see what's going on with this and get back to you.
Okay. We did see some Andromeda, though.
Yeah.
Yeah.
That's good.
That's the nearest galaxy to us, 2.5 million light years away. It's actually moving toward us and will eventually merge with our galaxy. Although there'll be no actual collisions of stars and whatnot, but the 2 black holes will have a strong gravitational interaction and eventually probably merge into one black hole. But it'll be quite the show in the sky, probably all kinds of new nebula, new star forming regions forming. However, it's about 5 billion years from now, so you might have to wait a while.
That's right. That's awesome. Well, it looks like Norman's ready to play some music for us. That's great.
My usual Global Star Body song here.
Yeah.
Well, you have a choice. I give you a choice this week. Either an old Tom Waits song called Heart of Saturday Night, or I also have my 12 strings here. I could play Billy Joel, Piano Man. Up to you guys.
What do you guys like? I'm not going to pick it. I like everything they play.
Piano Man on the 12 string would be cool to hear.
Yeah? Okay. I'll change guitar then.
Too old.
It's an old guitar. It's 1970. Norman, made in Quebec, too. Okay. You hear well? It's 9 o'clock on a Saturday, really crowded Shackleton. There's an old man sitting next to me, making love to his tonic engine. He said, sometime you play me a melody, I'm not really sure how it goes. But it's sad and it's sweet, and I knew it complete when I heard a younger man's clothes. the piano man, sing us a song tonight. While we all in the mood for a melody, you got us feeling alright. Now John at the bar, he's a friend of mine. He gets me my dreams for free. And he's quick with a joke while he light up the smoke. There's some place that he'd rather be. He said, Billy, believe this is killing me. As a smile run away from his face. Yes, I'm sure that I could be a movie star if I could get out of this place. La, da, 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 la, da, 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 la, da. Sing us a song, you the piano man. Sing us a song tonight. Are we all in the mood for a melody? You got us feeling alright. Now Paul at the bar, Paul's a real estate novelist. Never had time for a wife. And he's talking with Davy, who's still in the Navy, and probably will be for life. And the waitress is practicing politics as the businessman slowly gets stoned. And they're sharing a dream, it's called loneliness, but it's better than drinking alone. Da, 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 da. Sing us a song, you the piano man. Sing us a song tonight. While we all in the mood for a melody, you got us feeling alright. It's a pretty good crowd for a Saturday, as the manager gives me a smile. As you know that it's me that they're coming to see, to forget about life for a while. And the piano sounds like a carnival, and the microphone smells like a beer. And they sit at the bar, putting bread in my jar, and say, man, what are you doing here? La, 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 la. La, 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 la. Sing us a song, you the piano man. Sing us a song tonight. While we all in the mood for a melody, you got us feeling alright. Thank you.
Oh yeah, yeah. The loved it. Here we go. So Mike's breaking out his guitar.
Oh.
Oh, okay. That's good. That's good.
I already explained. I lost my singing voice over the past year. So no, I was just playing along with Norman. He's cranking that 12-string really nice.
Yeah,
thank you.
That's right. That's right.
Thank you, everyone. It was a pleasure again to be with you.
Thank you so much, Norman. Thank you for sharing as you do.
Enjoyable. Yeah, really.
Thank you. All right. So waiting all the way down in Argentina is Cesar Brolo. And Cesar has taken us to historic observatories, and he has shown us amazing views of the planets from just on his balcony. So we are Really happy to have Caesar with us today. I know it's cloudy down there, maybe raining, right?
Yes, it's raining in Buenos Aires. It's stormy with lightning bolts, and it's
Lightning bolts.
no time to go to the balcony. And
Uh-huh.
I am today in my living room,
Yeah.
and but awaiting this weather condition for tonight. Yesterday, I collect some pictures in the after the noon of making solar image. But the first thing yesterday that was holiday in Argentina was that I don't have solar filter in my home, and fortunately I found a film, a real film safe, a real safe film for solar eclipse.
Oh, yes.
Because if I talk about after that Chuck talk about the safety and solar, I say, come on, no, of course that I am telling for the people all time about the safety that they need to take care, really very concerned to have really a lot of safety points to make a solar filter. Here we are in our company, in our business, we are selling this year the solar shades, the glass or glasses,
Yeah.
and we are selling the film in cut in a different size, because yes, my idea first was import the extra scientific solar filters that have the framing cardboard, but this year we have so complicated import condition for this new environment that they say, okay, we can import only the film in a roll, and we prepare the glasses.
Yeah, make
And
it yourself.
in another way, yes, we sold the film. But no, when the people ask me, I ask to the people that how to make a safe film, no, sorry, a safe, sorry, filter, solar filter with the film. And was I had my own experience yesterday, because I say, okay, all the time I told to the people, I did a lot of solar filters with film, with this film, but yesterday with a very low quantity of materials in my home, I thought how I can make a solar filter with the performance to make it in a safe mounted a safe
Filter holder.
way to make absolutely. And first of all, the people told me, yes, but what type of cardboard? I don't have cardboard to make this solar filter. Okay, but I send you the film in a box. This box is of cardboard, and and first of all, I make the same of this.
Yes.
I make a hole, of course.
Yes.
And here I have my homemade solar filter.
Okay.
Of course, that is made of duct tape and cardboard, and
Got it.
work, and it's safe. And for different telescope, you need to make really sure that with the wind or something, you can't remove this in middle of the solar observation. This only it's like this, like a ring, but you need to have a lot of sorry, in English I don't remember the name, when you make something that we say in Spanish montaje. Montage is, I don't know if it's in French, but I don't know. But you need to make something really, really in a safe
To
way.
mount the filter onto?
Yes, and here normally we make something like a L shape that adjusts properly to the telescope. Last year we make all this in a plastic material, or sometimes we use 3D printers. Of course, that this is something like, okay, if you like to make this in your home,
you can.
You can. Yes. Okay. No. Yes. I felt like returning to the kindergarten making this. But well, I have pictures. I have really the worst part is that I felt sure is confident to go to the balcony and make pictures with this and put my eyes too, because Mom, I am an optician.
Yeah.
Yes, I'm
right.
Yes. Okay. Let me.
You weren't afraid.
Sorry,
You were not afraid.
sorry, Chuck of the League of Astronomy, because yeah, sorry. I'm sorry. And well,
see what you got.
Yes, this is first of all the materials. This was real. Duct tape, the cardboard of the same box that where the people received the film. This is the black part of the film. Because this is very important, because they use the same material in your filters, and instead another materials in the past more able to break more with less thickness. This material is really safe in two ways, because first of all, the base of the material, the polymer, is a CR6. That is the same material that used in the glasses of your in your glasses. It's the same material. 636 is a military grade material, and before they have the layer of aluminum, and this made a safe product. And the ISO norm is that do you have 12312 2 is the norm of safety where do you use this. Well, this is my own work with the tape. Really, I felt confident with this. I don't know why, but so I really sometimes I like to return to my first time of to be an amateur astronomer, and I like this. I never make this. Normally I make this in a 3D printer, or in our mechanics facilities, or okay, but
it's fun to
was
handle.
Yes. Okay, and this is with the XXIII of the balcony, ready to go to the sun. And working. This was yesterday. Here I use it again. I found how to
showing us pictures right now, because we're seeing a folder with pictures. Do you have a full screen picture that you're trying to show?
Yes. This is.
Oh yeah, we don't see the full picture. We just see the.
I'm sorry, but this is because it's only.
Do you have two screens?
Okay, no, because it's a cell phone picture. Sorry. No. Yes, this is the best way to because it's too small. If not, this is Molly that they tell me.
I mean, we're seeing a folder with pictures as opposed to a picture that fills the whole screen.
Ah, yes. No, yes. You can see the pictures that I show you now.
I can
It's
see
very small pictures.
all the pictures showing it at once in the folder.
Now?
Yeah, there's 1, 2, 3, 4, 5, 6, 7, 8, 9,
We're
10,
seeing
11, 12, 13, 14 pictures.
Present.
Okay, it's weird because yes, you are watching. Yes, you are not watching the. You're watching only the. Let me check. Sorry. Okay.
You might need to share your whole screen.
Yes. Yes. I need to share. Yes. Let me try. Okay. Let me check if I can share now. Yeah. Now here, it's okay.
There we go.
Yes.
That's it.
Yes.
That's it.
No. Yes. Okay. Sorry. Well,
problem.
here. No. Yes. You see the small ones, the thumbnails. I'm sorry.
Yeah.
Well, here we have. Now you can see that this was real. I prefer show the thumbnails.
I was following along on the thumbnails. Okay.
Well, yes.
Uh-huh.
Okay, and this is that made in the holiday when I was worried.
Yeah.
Okay, and here, well, this is where we can see that the filter is put in the telescope.
Yeah.
Working properly here.
Nice looking mount.
Yeah, it's good.
Yes. The best of all is that I recover my Wi-Fi connection before write a email, desperate email to Jerry. My son asked me, come on, you have a lot of tools in the computer about the Exos 100, the PC, the PMC system, and he teach me how to recover the Wi-Fi connection. It's really easy, but the best way was yes. I love this mount. It's not the first time that I tell this.
Thank you.
And
thank you, Caesar.
It's real. It's real. I talk about really about this because but something that is excellent for this type of mount, when you have a mount that you can make a line with the stars, because you have the daylight, you have the sun, and the best way is put the mode auto line mode and leave the mount to go to stars that you can't see, but when you go to the sun, you go near to the sun, and you need only to point to the sun. Go, of course, watch it with the filter and or with eyepiece or in the screen, and only put synchronize, and you have the sun really tracking perfectly with a Rowley equatorial alignment. This is the best way because I chose this mount for the show in the clips because it's the most trustable system that we have.
Wow.
This is a really a good choice for our show in 3 weeks more in the Eclipse.
Wow, great.
Well, here you can see the spots. This was really, yes. This was a lot of fun in a sunny day.
Yeah.
Very easy to enjoy. This is very important that I found with 3 steps I had a lot of fun in without complications, and this is the things that I like to encourage to the people. If the people love to use a telescope,
Yeah.
you know, well, here you have the video, the streaming, using SharkCap and a very nice, a very small and nice camera, planetary camera. That is a new brand. It's Symphony. Work properly. It's nice. And this was later in the night with the same system with the moon. We say Apeninos mountain in the moon.
Mm-hmm.
Another picture that I processed a few minutes ago. And here,
very nice. Yeah, that's
yes, the final results for this filter. This. let me show you with a little more of. Not a lot of here. No more than this, because I put a lot of wavelengths and I make a little of artifacts, but work properly. And the Exos 100 work really proper. Really good.
Thank you.
It was a pleasure.
Thank you. That's great.
Every time it's a pleasure, Scott.
Yeah, it's great. You have been on many of our Global Star Parties. I really appreciate it.
Yeah.
Thank you. Okay, so how about Molly? Did you get?
I got the Helix back, although it's not as good as it was earlier, but
That's okay.
you can still kind of see it. Also, here beside me, I have one of my cats. This is Orion, and he's happily snoozing on top of my green screen.
I see.
Looks a little funny because there's a flashlight on him.
Yeah, it does look kind of bizarre. Looks like a lump of stellar material kind of glowing out there.
A little bit. It's not so
Right.
bad.
It's funny. Mm-hmm.
All right, well, let me go ahead and share that view here. Oops. And then switch back over. All right, so.
Oh, there it is.
Yeah, you can kind of see it. It was better contrast earlier, but it's getting lower in the sky. I think it's about to go behind my lemon tree. But this is the Helix Nebula, which is I think it's the largest, from our perspective here on Earth, planetary nebula. And because it's so large, the light is spread out quite a lot over a large area. So it's actually pretty hard to spot visually, although I did see it once with a nebula filter that helped bring it out. It's also pretty low in the sky for us Northern Hemisphere viewers. But this is a hydrogen alpha view. So I have a hydrogen alpha filter in there, which is selecting a wavelength of the deep red, 656 nanometers, that is an emission of hydrogen gas that is excited by stars in space.
Okay.
And it's very common. That's where a lot of the red comes from in all those nebula images you see, or kind of the greenish, orangish color in a lot of those Hubble pictures and stuff like that. Planetary nebula they're actually the end stage of main sequence stars, much like our own, of about the mass of our own sun, that are in their death throes. They're at an end stage of their life where they're ejecting tons and tons of gas off of them in all directions, not evenly, which is why they have some really cool structure and stuff like that. The Dumbbell Nebula, the Ring Nebula, those are some other examples of planetary nebula from different angles where we can see that structure in different ways. So we're kind of seeing this one face on like the Ring Nebula, but bigger, basically, because it's closer to us. I think it's only like 700 light years away or something like that. It's really close.
Oh, that's close. Jeez.
Yeah, I'd have to go double check that figure. Yeah, it glows both in hydrogen and has a lot of blue in it as well, a lot of oxygen gas that glows really brightly on this teal blue wavelength. Although I'm just looking at the red here with this hydrogen filter.
So Molly, are you when you make astrophotographs and you make color astrophotographs, are you do you really try to match what you think the real color is, or do you think that that you could assign any color to a nebula to bring out details?
It depends on the data that I'm processing and how I want to process it. So most of the time, a lot of my data is wideband color, so red, green, blue, and then I'll enhance it with red from hydrogen alpha gas, and hydrogen alpha emissions, and blue from oxygen. And I try to keep as realistic of color as possible for those wideband color images that I enhance with narrowband data for better color and for better detail. But if I had access to a sulfur filter, which I've been able to borrow a few times, sulfur gas also has a very strong emission line that's actually very close to the hydrogen line. Mm-hmm. It's also a deep red color. Now, if you were to assign those their natural colors, you wouldn't be able to tell the difference in where the hydrogen gas was versus the sulfur gas because they're both a deep red. So that's why things like the Hubble palette exist, where you assign sulfur to be red, hydrogen to be green, even though the actual light is red, and oxygen to be blue. That way you can see in the nebula where the different types of gas are. And even though it's not a true color image like how your eye would see it, it still has a lot of scientific value and also makes for really gorgeous images.
Oh, sure. That's true. That's very true. Well, wonderful. That's great. Well, on the other side of the hemisphere, we have Rodrigo Zeleda with live images through his telescope in La Serena, Chile. So let's go down to La Serena and visit with Rodrigo and what he has in his telescope.
Hi, Scott.
Hello.
Now in La Serena is a clear sky, and I look in the Orion Nebula with my Explore Scientific Apple refractor.
Wow, nice.
and I make a composition for different time of integration.
Mm-hmm.
Of the center of the Orion Nebula in the center, this little star, with if you take a long exposition photo, the center of the nebula is very light. And do you know the detail is very, very difficult. And I share with you my screen.
Okay.
Okay.
By the way, Rodrigo owns a telescope shop called North Optics. It's the only telescope shop in La Serena and one of the few telescope shops in all of Chile. Maybe the most popular telescope shop in Chile. Okay.
Sounds good.
Mm-hmm.
Okay. This is a short time exposition. And in the center, the nebula is good details. And I take 10 photo for 30 seconds. Late, I photo for log position, and another photo with more time exposition. My idea is I make a composition for this different exposition time for the area in external of the nebula need more exposition time, but in the center of the nebula, it's more
already,
time.
Yeah, it's already getting very bright.
Yes, it's very common with the photo. You like photo like this in the center. Do you don't see the little star in the nebula? It's very difficult. A great photo which detail the little star, and it's a work for many pictures. Do you stake and combine for the good photo? And this is my scheme with the camera. Do you see my screen, Scott?
Yes. Yes, I do.
The QA camera?
Mm-hmm.
Yes. This is my photo now for the Orion Nebula with this time exposition. In the center is very light. And I combine this different exposition for the final photo. And the last night, the last star party, I take picture for the large Magallanes clouds in the H alpha struct, and
oh, cool.
share with you my last my last photo. This is my photo for the H alpha region in the.
Oh, wow. So this was the last star party, right?
Yes, the last part I check with you one shot, and this a 10 shot of this area.
Wow.
It's very nice nebula in the near for this galaxy.
Yes. Amazing.
I think that one that's near the center with the red and then the blue circle, I think that's where the Hubble, the 30th anniversary image that they released earlier this year is of.
Oh.
Yes, this area.
Yeah. Yeah, that blue circle thing looks very distinctive, familiar from the Hubble image that I saw recently.
Yes.
Special anniversary image.
Yes, in this galaxy, it's many areas for these structures. In the more important structure is the Tarantula Nebula. It's more bigger, and many with the wide view telescope is great for the astrophotography.
Oh yeah. Yeah, you can see
this is
this image. from Hubble is, of course, bigger and everything, but you got a lot of detail in your shot.
That's good.
Beautiful.
Yeah, yeah.
Beautiful. Thank you very much, Federico. Thank you.
Sounds good.
Okay. Yes. Okay. All right. So we will go to Mr. Richard Grace. Richard, what do you got for us? I know it's cloudy out there.
It is cloudy. That comes with the new gear.
Mm-hmm. Oh, you bought new gear. Okay, that'll do it.
Oh, you got an Exos too?
It is.
Cool.
But I do have one thing that I haven't shown off yet.
That's nice. I like the colors.
Oh, very nice. Yeah, very nice.
Yeah.
Tell us more about this image. Of course, it's the Orion Nebula, but any?
I think it was 1 minute exposures, but I could be wrong.
Mm-hmm.
It was a lot of them. I knew I was going to blow out the. I always forget the name of it.
Trapezium.
Yeah.
Very good.
Trapezium.
Excellent.
Trapezium. Uh-huh.
Yeah, I knew I was going to blow it out, but I did a good job of kind of separating that last year, and this time I just kind of wanted to go for nebulosity. I even probably pushed it a little bit far, but it's still early. It's Orion season, but
It's Orion season.
you know, all winter long. You know what I mean? We got plenty
You
of
got
time.
your Orion hunting license with you, or?
No, just the hunter safety card, but you know,
Take those photons. You
Gonna
know,
go bag some stars. You know?
right? Go bag some stars. Bag some
Yeah.
photons.
Yeah,
back to
photons,
photons.
absolutely.
That's right. That's right.
Yeah. So hopefully we're gonna get some clear skies here sometime
Okay.
soon.
All right.
Test
Okay.
out some new gear, and I know that there's a astrophotography contest going to be finishing up right before Christmas. So that's part of the reason for getting the Explore Scientific mount. So now I can
Sure.
participate in a
Sure.
few more categories and
Nice.
be putting some work in towards that. And yeah, really not a whole lot else going on here. I definitely can't fill a 10-minute segment tonight.
Oh, that's no
but
problem.
Wish
That's
we
no problem.
had.
I just wanted to see what you had for tonight. That's great.
Yeah, they at least I had something. Try to at
yes,
least
you
bring
did.
something every week. So
Yes, you do. That's good. All right, so let's go all the way over to the UK to Gary Palmer. Gary has been a very busy guy and hasn't been on our programs for a little while, but glad to have you back, Gary.
Hi, Scott. Hi, everyone. Hope you're all keeping well.
Yep.
Yeah, just the usual over here. Bit of cloud, bit of rain, bit of clear sky.
Mhm.
And just rotating that around, really. So tonight I've not really got overly much. I've just been working on something in the background. So I'll run that up and just run through what we've done and where we've got to with it is probably the easiest way.
Sure.
So let me just share a screen up.
Even your leftovers, Gary, look pretty good. So
Right, well, that's what we've started with.
yeah, that's nice.
After it's integrated.
Okay.
So we've had to mess around with this a little bit just to get some color out of it and bring all the detail out. So pretty simple processing on this, no major massive techniques on it. Just did a simple background neutralization. Then we went into color calibration on the system. Once we did all of that, it's resetting everything back down. Then we did the noise reduction on the background, multi-scale linear transform. Most of these processes we've done in the previous star parties right the way through.
Mm-hmm.
And then we did a mask stretch on this. And that's really to hold core detail in the image and not get the background too bright. So doing the mask stretch on it, and then we just reset that. So now we can see it's looking pretty dull. Still lots of detail there. And moving on, adding in a little bit of color using color, the curves transformation tool to bring that in. Key thing is with that is not to go too mad, because we're going to do other processes with the image. Yeah, if you add in too much color, you're going to distort the color, yeah, as you move forward. And really what we're after is bringing out a lot more detail in the spirals on the galaxy. So moving on from there, we added a little touch more color on it. Yeah, and then morphological transformation was just to pull the stars back and just shape the edges of the stars. You generally find with a lot of these objects, there's too many stars in the image anyway, so they take your eye off of the object. So quite often dim some of the brighter stars down using that process. As you can see there, once that's done, then I did a star net on it. So I removed the stars out to do the next processes, and then went on to, so we've got the separate star mask there. And then I made a luminance layer and did the detail work on the luminance layer, which is quite straightforward. It's nice and easy to do. And then we combine the luminance layer by splitting these into their RGB channels. So we basically end up with an RGB, and we can add those in with LRGB. So we're adding the luminance back in with all of the detail, and that again is preserving the color in the background. Once we got to that stage, we combine the stars back in, a little bit of contrast, and add some color into it. And that's where we got to.
Beautiful.
So a little bit more work to do on it, but that was basically what I've been working on in the background while been watching the Star Party.
Right.
Apart from that, not a lot else is really going on at the moment. I did do, where are we? That is actually in there. I haven't processed any of the images, but we did manage to get some of the sunspots today, which are better ones are down there. And that was it. So we've got the new large sunspot group coming round.
Oh yeah. Now this is the same sunspot that Caesar was imaging, I think.
Yeah, it's just here today. It was quite late in the afternoon and the sun's low, so getting onto these was actually quite hard. But it is looking like they will show quite a lot of activity as they're moving around. I did see a time lapse from this area earlier, and it looked like there was quite a lot of activity going on in there. But at the moment, the UK is not best place for imaging the sun. So that's about it, really. That's as far as we've got in the UK at the moment. Yeah,
thank you.
There's images there. I just haven't had time to process all of them, so we'll get around to that over the next week or so.
Sure. Gary, how many images, will you process in a given month?
I can't really keep count of that. There's something like probably 200,000 images on the hard drives, depending on what we're doing with solar, lunar, planetary, and then all of the customers' data coming in. So we're taking in customers' data, because generally if I'm working with a customer, it's nicer to work on their images. If it's all possible. Then you've forever got the systems downloading and bringing stuff in, and that's quite a long process depending on what cameras they've used, how big the image files are, and what we're working on. So I'd hate to say what we process in a month. It's nowhere close to what we actually put up online.
I see.
Probably only put up 4 or 5 images a week if we're lucky online.
Okay.
Actually processing in the background, there's probably anything up to 100 images a week.
Mm-hmm.
Getting processed, and then you would add your solar on.
I see.
Yeah,
so it's always a work in progress, I guess.
Yeah, and it's really funny because imaging from the UK, you can't just turn around and do lots of processes, because you are taking each image as it comes up to you on face value.
Sure.
Once you've got it integrated together, or once you've got it stacked, you're looking at each image as it is. So therefore, running processes on them doesn't always work where we'd run one process on that image and then move it over to the second image. There are some processes there. So it does take quite a lot of time, certainly on new equipment. If we're working on prototype equipment in the background, we'll be trying 20, 30, 40 different processes to make the best of those images. And a lot of the images come through damaged in one way or another. That might be through not having a matched reducer flattener. It might be because of other reasons. I mean, this week we've had a new filter drawer over, and it seems that it's getting condensation inside it, even though it's got a heater strip running down by it. So it's a good idea to sort of check the images every half hour and actually pull an image out of the capture and throw it into a piece of software like PixInsight or AstroArt, so you can stretch the image up and really see what's going on in the background. Because you can correct anything then. Otherwise, you waste your whole night. You know, you get up in the morning, put your images on the screen, and you go, "Wow, they're bad."
That was all a wasted night.
Yeah, not a lot I'm going to do with those, and trash them all. So it does pay to do a lot of that sort of thing. But at the moment, because we've had poor weather, there's a massive backlog of equipment to go through. So we're running, at the moment, I'm running through quite a lot of equipment in any one night just to try and get that through the processing system. So it's not all just dealing with customers, because as you know, we're dealing with companies in the background where we're working on different equipment. We get sent new things for reviews or whatever. So if you get a bad month, you end up with 30 boxes sitting there to deal with in, you know, 2 nights or something to try and get through most of that.
Yeah.
And there will be mistakes there. You know, I'll make mistakes on things. You don't know everything. You pull it out, it's brand new. There's no manual for it, no nothing. It just turns up in a box with a packing.
Yes.
And you've got to sit there and work everything out, yeah, as you start running through. So the first couple of images, if they come through really good, it's like result. We're straight on it then, we're imaging. Otherwise, it's out there measuring everything and working everything out so we get spacing correct, or, you know, we might have 20 or 30 reducers here to try out on something to get it actually up and running.
I see.
So yeah, it keeps you on your toes is what really what we say. Keeps you running around and keeps you busy.
Yes.
You got as full a plate as I do. You got as full a plate as I do, Gary.
Yeah.
It's like I got a bite out of every little dish in the whole buffet. You know, it's like 1,000 things on the buffet that you got to taste.
That's true.
Yeah, it does go mad some weeks, and obviously, like where we're doing the processing courses and working with customers, it's not just processing. So it's working on their equipment. They might have equipment that we've never seen before. You know, equipment on the other side, over your side, can be different to ours. It can have a different spec. It can have different things on it. So you end up doing a lot of reading and a lot of working out on equipment you've never seen before. It's not even in your hands, and then trying to advise the customer how to use that or get around the problems. So yeah, and that's also working on a different time zone. So, you know, if we're working on a Californian time zone, there's 8 hours difference between us and them, and that means an early morning finish. You know, once you sort of running through everything, but it's good fun. It's nice because you're seeing all different equipment, you're seeing all different people, and you never know when you go into a Zoom meeting what you got sort of sitting there waiting for you. So it's a different thing each time, whether that's with a company or whether it's with a person.
Right. There's always something new to learn.
Yeah, yeah. You never stop learning. You never stop learning.
No.
Because really technology is taken over in it, isn't it? It's the old days of just working on a set of maths for a telescope and a lens. Yeah, they're out the window now because of the amount of technology that's coming in, whether it's through computers connecting up, mini PCs, ASIs, Eagle units, all of these different things, and then the way they're controlled and, you know, supporting that as well. It takes quite a lot of working out with this equipment, where it's going and solving different issues for different people. You know, so like what I said before, you can get one computer and half the cameras won't work on that one computer for some reason. It's
Right.
trying to work out the reason why, and that could be a real top end, you know, Alienware gaming computer, for instance, and you'll plug half a dozen cameras into it and they're not working. And it's normally to do with the background of the Windows system or the background of the operating system is the reason why it's not working. You just got the headache of working that out.
Yeah,
You
we
know,
run into
Gary,
that.
I don't know of anyone that that you could go to that has the range of combinations of gear and the depth of knowledge that you have about all different kinds of brands and products and combinations of things, you know, because people, you know, as Jerry points out in his book, Scientific Imaging, you know, he takes you through the process, the mental process of creating a, you know, an astronomical imaging system. But there are all these little nuances, you know, about it. You can get it to work to a level, but to make it perform at its very, very best, you know, you need, frankly, you need someone like you to be a mentor to them. And so, you know, it's wonderful that you offer that service.
Thanks. I enjoy doing it. I really do. I enjoy. My key thing is not actually getting the images and processing them. That's just a byproduct of what I really do.
Yeah.
It's actually getting all of this equipment together and getting it working. So you get half a dozen boxes turn up, and it's actually getting all of that equipment to work together. Because when it's sent through, quite often nobody's actually had it working. It's normally, you know, it's on a CAD drawing, and then it's manufactured, and then it's here, and then it's the process of getting that together. So the thing I like is actually getting all of that equipment together and getting the images far down the line. Once you're seeing them up on the screen there, you're going, yep, that's, you know, that's where we want it to be.
Mm-hmm.
And as you know, dealing with problems on things can take quite a long time. So, you know, a piece of equipment might be pulled off. It might sit there for, you know, 3 or 4 weeks while we're trying to work out what needs changing on it, and then back to the drawing board. But that then leads to the end customer having a unit that's fully working and fully up and running. You know, they don't see what goes on behind the scenes in the background, in a sense. They pull it out, set it up, and away it goes. And that's the key thing. But I do find these days I have to write a lot more stuff down. The memory's going a little bit as I'm getting older. You know?
Right. It's always good to document things.
Oh, yeah. Now, Gary, do you mostly work with manufacturers, or do you work with individuals, or is it 50-50? Or?
It's really everything.
Yeah.
It could be vendors. You know, some of the vendors want us to work packages out and equipment for them. Manufacturers, different ones here and there. So sometimes you won't do work with a manufacturer for a long, long time, and then all of a sudden they come out with something, and you know, away we go. We're up and running with it. Quite often with a vendor, it might be a new piece of equipment that they've taken on. So we're there to sort of test it for them and really advise whether they should buy it or not is the long and the short of it. If it's good, they're going to stock it. If it's poor, you know, then the actual manufacturer of that equipment needs to do some work on it. So you just never know what you're going to pull out of the box, because it can look nice. It can be all shiny and brand new, and you go, yeah, wow, not seen anything like this before. But the actual performance on it can vary, you know. No different to the equipment coming in and getting drop kicked around by the courier. You know, it might have all been perfectly packed.
Oh, that doesn't happen. Gary.
And you know, you shake the box and you feel the movement inside, and you just know when you open that box that there's going to be a world of pain inside it. That's life.
You know, Gary, one time I went to the first time I went to the Winter Star Party, I was working at Mead Instruments, and I would build my telescopes so that I knew that they were built right and there was nothing loose or nothing bad about it, and test it, and then I would disassemble it, pack it in the box, ship it to where I need to ship it to. Well, I ship it across the country by FedEx, and FedEx has a station in Marathon, and so I flew out there, drove up to Marathon, collected my telescope, very confidently opened this box, okay, which had my sealed tape, mine, okay? I sealed it. So I knew it was mine, it was original and everything. I opened this thing up, and every bolt of this telescope had come loose. And I'm not talking about just like a couple of bolts that hold the four arms together. I'm talking about the motor mount bolts. I'm talking about the perimeter bolts on the corrector plate. The corrector plate was spinning around, all this stuff. Now, if I had not packed this thing myself, I would not believe, because there was no dents on this box. There was no damage that you could see, okay? And it was just, I guess, like high frequency vibration or something that made this thing come apart,
Yeah, I had one that went out to France, very similar to the telescope behind me. It was a Trust Newtonian.
Yeah.
And knowing what happens with this sort of stuff, I actually put a separate bag around the secondary mirror and taped the bag. And the customer did say to me that the secondary had more or less come off.
Oh, wow.
Yeah, in transit, but the bag had held it there, so it hadn't actually dropped down onto the framework. Hence the reason for the bag. You learn when these things turn up to you, how loose they are, or these things rattling around. And it's not necessarily anybody dropping it, it's just the motion and in the way that the box is set. But you do see all sorts of things go on. And the world of couriers is really a world of their own, in a sense. You never know what's going to go on by each company.
That's right.
When it turns up. I had equipment a few weeks back that was actually signed for at 8 o'clock on a Friday night, by somebody I don't even know. And it's meant to be here on the next day delivery.
Right.
It wasn't delivered, but so that they get paid, somebody signed for the box and then delivered it on the Monday.
Folks, these are the little things that drive us in the business absolutely crazy. So that's right.
It's one of those things. It's not what you can do about it.
That's right.
But it's all good fun. The industry is quite interesting. It's because you move from different areas. Certainly, what I do, dealing with sort of solar and lunar and the deep sky aspects. There's so many different pieces of equipment and components in that. There's always something new coming along.
Sure, that's right.
Gary, you and I have been talking. I don't know if you're going to have time we talked about you might want to write a book. And I don't know if you have time for that.
I think the reason it's been busy is really just a knock on with the pandemic. This is all it is. We were actually quieter earlier in the year. But then all of a sudden there seems to be a lot of new prototype equipment floating around, and you just go through a couple of months. So the last 2 months have been a little bit busier. Starting to quieten down again, but I expect the rush to pick up. Certainly coming up towards Christmas again, we'll start getting busy. But also with people getting time off, people work 7 days a week, very similar to what we do in a sense.
I don't mean to rush you or anything. I just made an observation. I think it's cool that you do a lot of great
the book's definitely something I want to do. So it's going to be a key thing of me making the time. That's really.
It definitely takes some dedication. It is, I've written 2 books for Springer, and it is a lot of work. There's no doubt about it. It's a lot of work.
It's a lot of work, but I think if you've been doing it a long time, a lot of the stuff off the top of your head without even thinking about. You can more or less do this stuff with your eyes closed, blindfolded,
right.
In a sense.
That's right. That's how I wrote my first book. I basically spent 4 years learning it and almost another full-time job, and then I dumped it out into the book. You know, it's like you've got all this stored knowledge in your head, and you just dump it out
Yeah.
into drafts, and then you work on it. You know, after you get all the material out there.
Yeah, I mean, I've been asked quite a few times to do it over the years, and I think it's more a point of when I'm ready to do it, and I feel like now's, the time. I always said I was never old enough. When I retire, I'll write a book.
I thought the very same thing, and then the opportunity came about. You say, "What am I going to do? I'm going to grab the opportunity and do it."
Yeah.
You know, you just do it.
Yeah. But you sort of, I work quite well under pressure. If I've got an easy week, not a lot gets done, even though I should be getting on with it. When I have a deadline there to get on with it is when I really sort of kick in with things.
Yeah.
I probably play quite well with a deadline. You know, it actually, I quite enjoy getting something up and running and done for a deadline, quite close to it.
Yeah, I'm kind of the same way. I get bored. If I get bored, I'm just lazy as hell.
Yeah.
You know, I need a challenge to keep me going. You know, really,
Yeah,
when it comes down
that's
to
it. That's what all of this is behind me. It's a challenge. Yeah, it's
Noted.
rotating around all the
It's a
time.
big, hairy challenge. Okay. We have a special meeting lined up tomorrow morning, Jerry.
Yeah, I know. You can pile some more stuff on me. Go ahead.
But it's no different with you, Jerry. You like it, getting the stuff up, and
yeah,
you sit there for months in the background working on something, and to get it actually physically there and up and running, it is really what flicks your switches. It's what keeps you sort of moving along. That time in between, when there's nothing more that you can really do apart from wait for manufacturer or wait for another part of the chain, is quite boring. That's where it all goes quiet. And then it normally gets busy once it comes out, and everybody wants to know the ins and outs of how everything's working on it, or sort of so on from there. But at the moment, I'm just waiting for really more activity on the sun. I've still got, a ton of work that we've been doing the last 3 or 4 years, and it's going to be putting that into practice now. Now that we're starting to get the larger sunspot groups come around, just need 2 big ones. Yeah, right side by side with the ribs in the middle, and that will do me fine. I've got me week's worth of work then to get on it and work all of that stuff out.
Well, Gary, thank you very much, man. Thank you.
No problem. It's always a pleasure.
Yeah, thank you. So, Molly, Richard, Jerry?
I did pull up that.
My telescope sequences are getting running, and both the targets I want to image are still behind their respective objects, trees, garages, whatever. So
okay.
I got nothing right now.
Okay. All right.
I brought that picture up from the Hubble Space Telescope that we were talking about earlier.
I could bring up a picture of the sun that I took earlier as well.
Yeah. Yeah, this is the part of our show where it's just kind of, you can freely show what you like, talk about what you like.
Yeah, sure. I'll go ahead and let me pull it over to this screen here. I'm in the process of processing them at the moment. Let's see. I'll grab this guy.
And we are getting a thunderstorm here.
What?
We are getting a thunderstorm here.
Oh boy. Let's see. I will share. I'll share the screen. Yeah. Okay. So here's a picture of the sun I took earlier. This is with a. Sorry, my cat's using the litter box back there. If y'all can hear that. Yeah. Oh man, that smells terrible. Okay, so so I have a Seymour solar filter that I got just like the sheet of it a while back, and I made a homemade filter cell for it that I'll show in a second. But it's just a white light filter. I don't have a solar telescope. but the conditions were good enough today that I was actually able to get some detail on those sunspots as well as the plages and stuff through a white light filter. So that was very exciting.
Yeah.
A lot of this other stuff is dust spots and whatever else is on
Dust
my
bunnies,
camera
yeah.
lens. And then here's the other sunspot here. And that homemade filter cell, much like Cesar's, was also cardboard and duct tape, and in my case, gaffer's tape as well, to just kind of, to make everything light tight on the inside. And then I put, like, at first it was black on the front, and I noticed the temperature inside got really hot. Like when I took it off, it was pretty warm in there, just from like absorbing the heat from the black tape. So I covered it with the white tape, and now it doesn't warm up in there at all. The white tape just reflects all the heat. So
it's a good idea.
Worked out really well.
Very good idea.
And then I put Velcro on either side of where the filter is at, on both sides of this filter cell. And then I put cardboard pieces on there on each side to protect the filter cell when I'm not using it. Because you don't want to get any pinholes or anything in it. Otherwise you can't use it anymore. And I decided to make an off-axis one because I only had an 8x12 sheet, or sorry, 9x12 sheet of the paper. And it's an 8-inch telescope, and that would have only given me a little bit on the sides, and it was just too close for comfort on whether I could make that and have it be sealed and stuff like that. So I just made the little off-axis one here.
Yeah.
This is when I was at the Mercury transit back in last November.
Yeah, it looks like you're having a good time.
Worked very well.
Oh yeah, that's great.
But yeah, so that's from earlier today, the sun image, and I'm working on processing that into, I'm gonna make a GIF to see if I can see any changes from frame to frame, or else I'm just gonna go through and clean up the single image and get that published, on my social media.
Awesome. That's great. Feel free to share it on my personal page, so happy to share your work.
Thanks.
That's great. Jerry, you have something to...
Yeah, I'm going to share this image real quick. This is kind of cool. You see
right. That's the 30th anniversary image.
Yeah.
From Hubble.
That's
yeah, Rodrigo had captured a lot of that detail.
Yeah, he did capture quite a bit of the detail in this area. Yeah, I thought that was cool.
Mm-hmm.
So we just have to just invest another $100 million into a telescope for us to use remotely from here. That's in space, right?
Would it cost that much?
I would imagine at least. Well, it depends on how big a telescope it is.
Could be a really small one.
We could talk to Elon Musk and see if we could hitch a ride on one of his.
You get a little 70mm quad,
Yeah,
just
get a
big,
right.
And then have a little
big imaging chip. Yeah, we could build a satellite, our own telescope satellite. The problem is being able to control the pointing would be difficult.
The guy who made that Hubble image, we had him on the Astro Imaging channel recently, Joseph De Pascal. He works at the what's it called, the I'm gonna get it wrong, but he processes most of those Hubble images that you see out there.
Oh wow.
And we had him on the Astro Imaging channel recently, and he talked about what that was like. And he uses PixInsight just like the rest of us, so it was very cool.
That's cool. That's cool. Well, it just shows you how advanced that program is too. So
yeah.
Yep.
Right.
How about you, Deep T? You have anything to share with us? No. You like hanging out with us. That's what you have to share.
Yeah.
You like hanging out with us. That's good. How about you, Chuck? You've been here the whole time. You're muted.
I'm unmuted, hopefully.
Yep.
Yeah, let me share with you one image here that I think is interesting. Let's see, view. Okay. This will show you what amateur astronomers can do now. This is an image taken with an 8-inch telescope by a friend of mine in Evansville, and a comparison of an image taken with a 322-inch telescope.
Good Lord.
Really,
not a lot of difference, really, except
not excessively, just resolution a little bit,
size
obviously.
of the stars. Yeah, that's right.
The tracking of the stars.
Yeah. But I thought this was remarkable, and it's an image I show. When I start giving programs about the League's observing programs, and I've been asked to give a bunch of those lately, there seems to be a lot of interest. One thing I start off by doing is explain all the reasons why people might not want to do that. If they're doing variable star work or imaging like many of you do, whatever you're passionate about, do that. But if you like visual astronomy, then the observing programs are wonderful also to direct you to new vistas. But this just shows you the work that can be done by amateur photographers.
That's true. That's true. It is. I remember early on when the digital revolution started taking off, and people started comparing their work against 1970s Palomar 200-inch images. And that was kind of the benchmark. It now seems like a lot of amateurs will benchmark against the Hubble, or something like that. So.
Scott, honestly, the images that people take of, especially planetary images today, exceed that of Mount Palomar.
Oh, I mean,
agree. No question.
I would agree. The images I've seen from Christopher Go and Damian Peach and some of these people.
They rivaled the Voyager. They rivaled the spacecraft, Voyager and Pioneer.
Yeah.
Right. Oh yeah. Absolutely.
No, I'm referring to Palomar days in the 50s, not necessarily what could be done with them today.
True. But even spacecraft shots done in the 70s,
Yeah.
Man, I tell you, the detail is incredible, including getting details on the moons around Jupiter and Saturn, in some cases. So it's wow, I love it. I love seeing amateur astronomers break the boundaries. You tell an amateur, you set up a standard that you think that no amateur could possibly do. And within months, often,
yeah,
they have figured it out and they're doing it. So it's really impressive. It's very good. Well, gentlemen. Ladies, any more to share?
Don't mind. So up to you. Depends on the time. If you want, I'm just waiting for a process to finish on here. Could run through a sunspot process as we've got a large sunspot coming round.
Sure.
Yeah. I just need this to finish saving what it's doing, and then I'll share a screen up.
Okay.
But, as we've got these larger sunspot groups coming round, it might be a thing to go through. I've just got to wait for this to finish writing about 10 files, and then it'll be ready. It's also worth bearing in mind that, like what Molly's doing now with the solar film, it's so easy. You can even use the solar film on a standard camera. Yeah, you can put solar film over the lens. Yeah, and image these sunspots. A couple of years back, we imaged them using the solar sunglasses in a mobile phone. Yeah, so we put the solar sunglasses over the mobile phone and zoomed in on that. And that was quite interesting. It was quite good to see. Let's see if we can get this up and running. If not, I will quit it. Yeah, it's actually stopped anyway, so there we go. Right, we use this one here. Okay, hopefully you can see that.
Yeah.
Yeah. So not too dissimilar from what's going on at the moment. We've actually got the two sunspot groups or two sunspots that are there. Hopefully over the next week they're start running some linking structures between the two sunspots. That would be nice to see. But there's nothing to say that it won't. There won't be another sunspot still ready to come round. The last active group that this came from in 2017, there were 3 or 4 of them, and that was on the decline. So they can all come round sporadically, really. You never know what's around the corner. So we're going to set this up anyway. We'll set it up as improved tracking, run it at global, and we're going to increase the noise robust, run it up to about 7 on this particular image. I've already set on one of the frames by running the slider along, and then we're just going to analyze it, let it run through. It is quite close. This, you're on about a 7.5 meter focal length into the sun, so that's pushing it a little bit from the amateur base, but it was done on under £2,000 worth of equipment. So that was quite interesting. Just a pretty standard 152 doublet, using a cork and then using some Barlows on the cork itself. Even though it's already got those in, we added some more to it and up the focal length to run through. So it's getting there. It'll take a couple of minutes for it to run through this. Can more or less use the same process. Doesn't matter whether you're zoomed in or whether you're on the a smaller aperture. Okay, when we get this zoomed in, I pretty much ignore the quality graph here. It will change, and it certainly changes a lot in the UK, just basically because of high cloud. So we're going to set it up for 250 frames out of the 2000, leave all the sharpened and everything alone, and then we're going to run the alignment points at 104 and place those across the image, and then we're just going to stack it. Okay, going to switch it over to Registacks. The image should come in. If it doesn't, then we'll resend it. There it goes. Okay, so we get it to show the whole image. And then we need to set up the initial layer here. This is the key thing as to how many numbers you run on the initial layer, depending on how zoomed in you are. So I generally run with a linear and a default on this. Start with the initial layer 2, and then run it up to about 40%, somewhere around there. That's a little bit too much there, so we're going to run back, bring it back down, somewhere around 22, and then do all. That's looking pretty good. So we'll save that out. And then we'll open that back up in Photoshop. Let's just close some of these screens down. In there. And there's our image sitting there. Okay, so nice and straightforward. Going to crop the stack lines off of the edge. Going to move it into grayscale. Yeah. And then we're going to move it into an 8-bit so that we can change the color on it. And we're going to go into duotone, set this up as a tritone. And when we double click on the colors, the spaces there, we're going to need a black in. So on the next one down, then I'll go to color libraries. You can play around with these. I personally prefer true match colors. They just give me a nicer blend on these. So run into somewhere around the oranges, just around there. And then we'll have a yellow for our next color.
Mm-hmm.
Got a little bit lighter on that. There we go. Okay, and then we switch it back to an RGB image. And we can start playing around with the color balance then. Really change this to whatever you want. It's down to you. And then we can bring in some contrast and that will tone it up. And then we're just going to do some noise control, despeckle it. Cancel that out because it helps if you pick the right filter. And then we just run some sharpening on it. Run an unsharp mask on there. That will just bring a bit more detail out.
Look at that. That's nice.
And then if we want some more black in there is to go into the actual selective colors. Yeah, so we can go to the blacks. I've actually installed another copy of Photoshop in here tonight, so all the settings are out of the box. But you would play with this a little bit more. You balance the image up. Yeah, either side. You can do all sorts of things to this. You could even come back, yeah, in your history to the point where it is an 8-bit image and it's grayscale. We could even run into something like HDR toning, yeah, and then we can balance this around a little bit more and play with this. This would bring out some more detail. And you can sort of work from there, and then you could go on and color it. So there's a multitude of different ways that you can play with this.
Wow.
But it's a case of getting the data to start with, and then you can play with the images.
Right. Beautiful, man.
Incredible.
Incredible.
I wonder if
Yeah,
anybody's got an APOD with like less than 5 minutes of editing before.
You know, it's something I never ever enter images for APODs. I
You've
put
never
them
done it?
online, but I just never get round to entering an image for an APOD. I never have entered any, I don't think, ever. So, yeah, they're all stored on the computer here.
Yeah. That's right. So what's happening in California, Molly?
Like in general? I'm wondering if
Yeah, in general.
it's rolled in because I'm still not able to get any targets acquired. So I'm going to pop outside here in a minute and see how things look.
Yeah, it
I got
is.
to take
Okay.
one snap off my context camera so I could see what's going on. So
Okay. Well, why don't we take like a 10-minute break, okay, and then we'll come back and see what else is left, and then we'll conclude the star party. Okay.
Okay.
Sound good? Okay. Great. Well, we're back, and our group is getting a little smaller. A little smaller.
Time zones, man.
Yep, that's right. That's right.
I got myself some ice cream in a Star Wars mug while we were out. I don't want to waste a whole bowl. I have tons of mugs, not a whole lot of bowls.
That's right. That's right. That's right. I eat my cereal out of a mug. You know, it's a good
Oh
way.
yeah.
To have it.
There's my other cat about to yank down my green screen. This is Apollo.
So you have 2 cats?
Yeah.
Oh, that's great. Yeah.
So it clouded out here. My whole sky clouds unexpectedly.
Okay.
Forecast still says that it's currently clear, but that's just life in the Bay Area.
That is so weird when like you put that green screen over there. It's like you're stretching the universe, kind of out to the edge.
It's kind of weird.
Right.
Let me show you a peek behind the curtain of the universe.
That's so funny.
Yeah. So no more images from me.
No more. Okay.
But I could talk about configuring like Sequence Generator Pro to bend it to your will if we need something to talk about.
Yeah, why not? Why not?
Or if anybody else has something else they want to talk about first.
Do it. Yeah.
I don't know how many astrophotographers watch versus like members of the public who would not be interested.
No, actually, it's a lot of astrophotographers. They tend to watch the end of the show. We have more astrophotography going on generally. But I've started. I like having peeks through people's telescopes that are that have something live going on as the show goes along because it's
it is a star party.
It's a star party, right? So
Gotta see some stars.
That's right. Well, how about you, Richard? You got anything for us?
Oh boy.
Oh boy. I saw you mention in the chat there that you've been thrown under the bus. What happened?
A friend of mine said I didn't play the guitar.
You do play the guitar.
I do play the guitar. Uh-oh.
Let's hear it.
After going after Norm, I don't know.
I know it's like going on after the Beatles, but Let's hear it.
Oh boy. Just a little jam.
Okay. A little jam is good.
Just a little rock and roll. Let's see.
What kind of guitar is this, by the way?
This is a Jackson Warrior.
Well, that thing looks cool.
I've been
Whoa.
Can you hear it?
Yeah. Now, were you in bands before? I mean,
really?
Not really. No, you just. All right.
My neighbors are gonna love this.
Oh yeah, crank it up. Crank it up.
I did.
I like it. I like it. Uh-oh. Yeah. I loved it. It's good. It's good. The guys in chat liked it. Very good.
Nothing like being put on the spot.
Yeah, that's right.
I think you did all right.
Yeah, you're with friends. It's all cool. Yep. Well, great.
So,
Well,
Astro Beard, I have a question for you.
Bring it on.
What happens if one day you don't have the beard? What will you call yourself?
Well, I'm hoping that I'll have a nice Father Timely beard on my corpse one day. So
Beard's gonna stay around forever. Is that the plan?
planning on it.
Cool.
Been around for a while already. A good 15 years.
Nice.
So when did
My
you
mother-in-law's
first
got a
grow a
pretty
beard?
impressive beard as well. I got him some beard care products for Christmas last year.
What are beard care products?
You know, stuff to clean it, condition it, brush it, you know, right?
I thought you just use like shampoo and stuff. Although I could never grow a beard, you know, so
I think the
you know,
beard
guys.
hair-
No, this is honest to God truth. The way I shave in the morning is I put cream on my face, not shaving cream, real cream, and then I let a cat lick it off. Okay. And that's how I shave in the morning.
It's like how we used to clean the basement floor. You spill bacon grease and let the dog lick it up.
Yep. Works great.
I'm no beard expert, but I think that the beard hair is a different like texture. It kind of has different needs than the top hair, you know.
I use the same thing on both and the same brush on both. I see the same care products that you've spoken about, beard oils and
Maybe it's all a scam. I don't know.
actually,
Yeah, it's gotta be. It's gotta be. Mm-hmm.
I know it did save my neck once from a road impact on a motorcycle, so it's staying.
Oh wow.
So here's some comments from the chat. Okay, from Norm Hughes. My mother-in-law has a beard too. Okay.
He doesn't see that.
You're going to get in trouble, Norm. You better be
That
careful.
was my brother-in-law. I don't know if I said that clearly or not.
If you've
Stefan
never
Del
seen,
Pra says, I've got some great Italian-made sandalwood beard shampoo I use for mine. Okay.
Sandalwood.
Sounds fancy.
if you've never seen the video of Dave Canterbury starting a fire with his beard, look it up. It's incredible.
I need to see this.
It's kind of a joke, but it's still incredible.
Is that like in a similar way, like steel wool and a battery?
Oh man! Except it smells horrible, I'm sure.
One of the only electrical fires I've ever meant to make.
Yeah, that's.
Sorry, my cat's knocking things off my desk, as cats do.
Mm-hmm.
Cat, out of here.
Norm says, I have a beard, but mine's close and short. Book Davy said he just shaved his off. And Martin Eastburn says, I use 2 dabs of shampoo on the head and 1 on the beard.
Cat's literally sitting on my
Chuck
drink.
Lewis says, my wife says, kissing a man without a beard is like kissing your sister.
Oh.
So let's see, between that one and the one with the mother-in-law that has the beard, those are pretty funny.
Oh dear.
So DT, in Nepal, do they have men with long beards or short beards or any beards?
Yeah, people switch.
They have.
Yeah, they have.
They have it. Yeah.
Yeah. My brothers, elder brothers, love to pull the beard.
He likes to pull the beard.
Yeah, long beard like Esther beard.
Yeah. Yeah. I just never could do it, so.
You gotta have something to stroke when you're thinking, right?
I just kind of do this imaginary, beard thing. That's right.
Nice
My
for those
fantasy
cold
beard.
astrophotography nights when you're out in the cold somewhere, not in the living room, controlling everything remotely. Did a lot of that to start off with, and
It's got to
looking
keep
forward
you
to more.
warm, right? It keeps your face warm.
Yeah.
I'll just get one of those, you've seen those crocheted hats that have like the crochet yarn beard attached to them. I'll just get
It'll
one.
work.
But I'm not outside a whole lot anymore because my telescopes they run pretty well. Sometimes I have to go unplug and replug a cable or go see if the clouds rolled in or not. But otherwise, I operate everything from inside. It's real nice.
Well, you're spoiled.
Well, it's taken a lot of work to get here, so
certain targets
happening in the last year.
certain targets go real well a lot further away from 100 foot away from that LED street lamp out front.
Yeah,
I have. So
well, see, when I'm out at the dark site, I sit inside my heated camper.
Oh, that's cool. Yeah, and you got a pretty cool camper too.
Yes.
So what is the most ingenious things that you've seen astronomers do so that they can get dark skies?
Like as far as darkening their local skies.
Their local sky. How do they darken their local sky legally?
I've seen people.
Well, I don't know if it's legal, but
like take like pipes and like kind of add an extension to their fence with like black cloth.
Oh wow. Okay.
I'm in the fortunate situation where I have like 6-7 foot high fences around, and then my house blocks the rest. So I don't get any direct light spillage, just whatever light reflects off of my neighbor's house.
Ambient out there.
So that worked. That was a very fortunate happenstance of the house that I got.
Mm-hmm. I had a client in Malibu that had an observatory. Now Malibu's kind of a nice, it's off in a, towards the beach area, and it seems like it's dark, but there's lights everywhere, And this guy had 3 street lights, and this is way before narrowband filters, and I said, so how do you deal with all these these mercury lights around here? And he says, watch this, and he flipped a switch. He had 3 lasers aimed at these 3 street lamps. He said, wait for it, and they all went out. Boom.
That is brilliant. I forgot that a lot of those have like light sensors on.
They have a light sensor on there, right?
To being, like switched on by some system.
So what would happen is that the neighbors would complain that the lights were faulty, okay? And they would send out somebody to go and change the bulb and fix it up and stuff, but he never got caught. So,
that is amazing.
Yeah, red lasers, no green lasers.
Yeah, you gotta do red laser, right?
I wonder if the infrared ones will work.
Yeah.
They're probably visible light sensors, but they might accept infrared as well, especially if they're cheap.
Even when the line guy comes out and puts his hand right in front of it, you wouldn't see it in that case.
Yeah. Jeff Wise says he. What's that?
The line guys, they're not going to come out and fix it at night when you're trying to use it.
No. Yeah, they just thought maybe there was a connector that was faulty or something like that. Jeff Wise said he tried a green one on his street light and it didn't work. So,
interesting.
But it does work. I've seen it work. So,
I wonder how carefully. I don't know how big the sensor is, if it's difficult to aim or not.
You can't just be like hand holding the laser because you're gonna.
Yeah, you'd have to set it up on.
It's got to be mounted, right? And it didn't take a very powerful laser. I don't think they were very powerful. So.
Daylight's not that bright compared to a laser that's relatively focused.
Norm Hughes says he's currently in talk with our electric company to shield one light on the street.
All right.
Asteroid Hunter says you get to know the guy who works on the street lights in your area. Show him what you're doing and buy him a beer. This will make and then he'll make adjustments to the street lights around you. That's what we did.
That's awesome.
That's probably better. That's right. More permanent, maybe. We do have a couple of programs that are coming up that I wanted to talk about. We have on December 4th, we have a live Mount Wilson event where we'll be going in through live tours through the 100-inch and 60-inch telescope, maybe through the 150-foot solar tower. And we'll have lectures with a Carnegie astronomer, and then we hope to do live imaging through the 60-inch telescope that evening. So that'll be cool. That's December 4th. On December 5th, we are doing a live event with the Astronomical League, and it's their first live program. And so this is for people that, of course, obviously league members, but and non-league members, and just people that might be interested in the league in general, or just like astronomy. It's going to be a good program. They've got great lecturers, and this will be co-hosted. I guess Terry Mann's running the lecture series, and you're going to be there, right, Molly?
I am. I'm going to talk about the how to get started in astrophotography as part of their new imaging program that you can work on, just like their observing programs.
Perfect. Yeah, and that's all I have for right now as far as knowing what's coming up. Of course, we'll continue to have the Tuesday global star parties. I may take a vacation. I haven't had one in a long time, so that may be coming up. But
is the star party for the Great Conjunction going to be on Monday?
It's going to be on the 21st, so we're going to have to figure out exactly when to pull that off. You know, yeah.
I'm going to a friend's house to get a better line of sight because I'll have no chance of even getting it here. There's good internet, but I'm not sure if I'll be able to stream it or not. So we'll see what we can do.
You know,
I'll most likely be able to stream it, depending on. I'm pretty sure I'll be able to set up at my house, but I haven't checked the sight lines really carefully yet. I think I'll be able to, but we'll see.
Yeah, Saturn and Jupiter are getting really low now, so. But I'm thinking that it may be possible, given enough aperture, that you could actually see Saturn and Jupiter in the daytime, or maybe towards the afternoon.
Yeah,
I know. I mean, I've done it with a 12-inch telescope. So.
I'm probably gonna start early. I can usually get them like an hour before sunset, even sometimes. So.
Yeah. Right.
They're apparently going to be so close. I was looking in Stellarium, and it said even with my small censored 183 with a C8 and a Barlow, that it's all going to be in the same frame.
And a Barlow. Okay.
And a Barlow.
Yeah, because I was looking at my C8. Pretty excited that it's gonna be able to be in there.
It's only 6 minutes of arc at closest.
Really?
6 minutes.
Oh my goodness.
So it'll just look like a double star up there, right?
Oh, that's gonna be so cool.
I want the blown out shot with all the moons.
The same eyepiece field.
I'm just trying to figure out what my odds are that I'm going to have a clear sky.
Yeah, right.
Yeah, I'm
Don't
working.
buy any new equipment for this, okay?
Yeah, everybody's just not buying.
Do not buy any new equipment for the December 21st opposition. You're going to be clouded out if you do. So
I actually delayed my trip to go home for Christmas by a day or two so that I could image
do this
part of the conjunction.
Your relatives know what you're doing.
I told my parents, I'm like, hey, so like I was gonna come home on the 20th, but like
there's a
Jupiter and Saturn are doing this thing, and they're like, yeah, all right, we'll see you on the 26th.
Okay. So, I read now. I don't know if this is all true or not. I believe it is. That it's supposed to be the closest that they've been in like 380 years or something like that.
Yeah, I think I saw the last time they were this close, like Galileo was alive or something like that. I haven't verified this, but it might be true.
21st, great, and they called it a great conjunction.
Sounds about right.
Right. Okay. So here we go. This is Wikipedia. Great conjunction is conjunction of the planets Jupiter and Saturn. They occur regularly, every 19.6 years on average, due to the combined effect of Jupiter's approximately 11.86 year orbital period and Saturn's 29.5 year orbital period. The next great conjunction occurs on the 21st of December, 2020. Let's see. Let's get to this one. The great conjunction of 2020 will be the closest since 1623.
I remember that.
Yeah. On the 21st of December at 1330 Universal Time, Jupiter will be 0.1 degrees south of Saturn and 30 degrees east of the Sun, meaning both planets will be visible in the same telescopic field of view, though they will be distinguishable from each other without optical aid. The two planets will be visible low on the southwestern horizon in the constellation of Capricorn after sunset. For mid-northern latitudes, the planets will be less than 15 degrees in altitude 1 hour after sunset. The Great Conjunction occurs 7 weeks after Jupiter passes Saturn in heliocentric longitude, a heliocentric conjunction. And this was...
Yeah, they are going to be 6 arc minutes apart. That's, yeah, maybe I will toss a Barlow on there.
Yeah.
Do you mind if I share my screen real quick?
Please.
It might look funny because this is an ultra-wide screen. But this is Stellarium on the night of the 21st.
Okay.
And if you turn the camera a little bit, you can definitely get them both in the same field of view.
Oh, right.
So that's with a C8 and a 2X Barlow and a sensor that's like 8.8 by 12 millimeter. It's pretty small sensor for the 183, but depending on what you're working with, you can use a lot of power and still get them in the same frame. That's all I wanted to really show, though.
Yeah.
There's the...
Awesome. I've got plans, many plans that are probably going to ruin my plans.
That's pretty good.
I practiced.
Work on that. Our evil laughter. Yes.
Everybody needs to have their everybody needs to have their evil, like, supervillain.
That's right.
Horrible laugh, you know.
That's right.
I don't have one.
I have to admit, I'm super excited about this December 21st event. It's going to be cool. So, yeah, anybody listening out there that wants to try their hand at joining in, I can have 50 people on Zoom at the same time. So it would just thrill me to no end to see 50 astrophotographers with live views of this event, you know, that we could scroll through and show people what's happening. So, and then, you know, after the event, all the processed images, I know there's going to be some spectacular stuff. So, I'll just be the man behind the curtain switching between astronomers. Yep. Well, so there's your challenge, folks. And we hope to see you on the 4th and the 5th and, of course, the 21st. But other events that we do, of course, we do daily shows, you know, with Jerry Hubble and Kent Martz. And it's a lot of fun to spend these times with you. And, you know, I hope that you're getting something out of it, because we sure do. So anyways, and thank you, each one of you, you know, Richard, thank you, Chuck, Michael, thanks for coming on your first time. It's great. Deep T, hope to have you on next Star Party. So, okay, I'll challenge you again, but I'll give you like maybe 48 hours notice instead of 24 hours notice on what it should be. I was amazed at what you pulled together, you know, really. So, now, DT, are you would you consider yourself to be good at mathematics or physics, or what's your specialty, do you think, in school?
In physics.
physics.
Yeah.
That's great.
Yay, physics.
Yeah. Now, DT hopes to come also to the United States and maybe go to school here. So I
Yeah.
hope that works out. And
Be.
yeah, yeah, and maybe you'll be working for NASA or something. You never know. So that'd be really cool. Well, I think
Yeah,
that's it. I think
yeah,
that
I have the photo click from the Libby and me myself. Okay, something. Yeah, we were discussing earlier when you are not here. Yeah,
I like it.
Nice.
That's
yeah.
good.
We are discussing about our cat in her school. Like,
Awesome.
Is your club growing, Deepti? Is your
yeah,
astronomy club growing? Good.
yeah, yeah. We are planning to have the program this day, but some of our from some of the members are from this high school level ending, and they have the examination. So we have stopped for now. So
Mhm.
after December 1, we will continue. And on December, we are planning to have a lot of program.
That's great.
Yeah.
All right. DT, thank you so much. Chuck, thank you
Thank
so
you.
much.
Yeah.
Thanks.
And Astro Beard, thank
Actually,
you.
I'm interested in league too.
You're interested in the Astronomical League?
Good.
Yeah. Yeah,
Yeah.
maybe you can make her club an Astronomical League club. That would be
Cool.
good. Give me an excuse to go to Nepal and check it out.
Hang on just 1 second.
Got Orion back up here.
Do you? Let's see it.
DT, I just
It's Orion.
I just messaged you.
Oh,
my,
not the.
Yeah, sorry, it's still cloudy, but
I got
this
it.
Orion is happy to share his views.
Yeah, that's
cute.
right.
Look
DT,
how cute he is.
I just chat in the chat window. I sent you my email.
Okay.
So just drop me a line, and I'll tell you all you need to know about the league.
Okay.
Thanks.
Oh, I'm just now seeing this message here, Chuck. It says if you need 5 minutes to fill, I do have a shortened extremes in astronomy slide set. Let's see it.
Want to do it now?
Yeah.
Okay. How much do you want? It's a full program, and I'm not going to do it all tonight. I'll just do the close-in items.
Yeah.
Okay. Hold on 1 second. Okay, I've got to find it again. Okay, give me 1 second, please.
I'm getting ready to send in my next my next award program.
How are you?
Yeah, I'm going to finish up the planetaries.
Cool.
Oh yeah, I'm about 7 short of those. I have to wait until February to finish those.
I finished it up a couple weeks ago.
Is that right?
Yeah,
It's a tough one.
it is.
Okay, let's see here. All right, let me share the screen. And we'll go here. Slideshow. The current slide. Okay, this is part of a program I did on extremes in astronomy, and it sort of starts close to Earth and then works its way to the depths of space. So this will be the close-in stuff for tonight.
Okay.
This one's the distance and duration record in space for humans. Belongs to Valery Polyakov of Russia. He was aboard the Mir for 7,075 orbits. For
Wow.
441 days. The dates are visible on the screen here. Covered 186 million miles during that time.
Goodness.
Quite a record. The altitude record is still held by the Apollo 13 astronauts, who of course had a little bit of a problem en route to the moon. But they looped around the moon rather than dropping into orbit, and the moon's distance from the Earth and the nature of their swing around took them to a distance of 249,205 miles from the surface, which is a record still. The speed record human speed record still belongs to the Apollo 10 astronauts from 1969 as they approached the Earth on return. They reached a speed of 24,846 miles per hour.
Goodness.
This is the first lunar landing, the first photo taken from the surface of the moon. This was taken by the Soviets who landed Luna 9 on the surface of the moon on February 3rd, 1966.
Wow.
And the first manned landing, of course, we all know Apollo 11. This was a shot taken from the LEM. And
that's a beautiful shot. I love this.
Which one? Oh, this
one here.
This one, yes, yes.
Well, no, the man, the man that's walking.
I'm sorry. There you go.
This
slide relates to the longest stay on the moon, which was Apollo 17. They stayed on the moon for 3 days and 3 hours.
Uh-huh.
The highest known mountain belongs, oddly enough, to a mountain called Rhea Silvia on the asteroid Vesta. Above the average plane of the mountain, it rises 72,178 feet.
Holy smokes.
Which is just slightly higher than Olympus Mons above its average plane.
Wow.
The first unmanned landing on another planet, of course, was Venera 7, which we heard from Dave Eicher about earlier tonight. The spacecraft, of course, essentially melted after about 15 or 20 minutes. I can't remember the exact period of time, but it didn't last long with temperatures in the 800 plus degree Fahrenheit range and 90 atmospheres pressure. That's 90 atmospheres pressure, by the way, is about the equivalent of being 3,000 feet deep in water, to give you an idea of the pressure on the surface of Venus.
The guys in the chat are saying you're giving them answers to the future contests.
I'll try to avoid that if I can.
How good is your memory, people?
Exactly.
Yeah, look into this blinky thing here. Yeah.
Yes. This is the fastest spacecraft ever. This is the Parker Solar Probe. And on January 29th of this year, it reached a speed of 244,225 miles per hour relative to the Earth. Yeah. And on December 24th, Christmas Eve this year, it will reach a speed of 450,000 miles per hour relative to Earth. So there's your new record holder. Most distant unmanned landing, of course, we also heard about tonight, was the landing on Titan by the Huygens lander on January 14th, 2005, at a distance of 885 million miles. Incredible stuff.
Yeah.
First asteroid landing took place in 2001 on the Near Shoemaker mission to Eros. It lay at a distance of 158 million miles.
Cool.
And this is a picture taken from the surface.
Lots of gravel.
Mm-hmm. And of course, the first comet landing, the Rosetta mission, the Philae lander, landed on 67P Churyumov-Gerasimenko in 2014. Just an incredible mission.
Still can't believe we landed on a comet.
I know.
I mean, what?
Yeah.
It's amazing. And the thing that makes it so hard, of course, is the gravity is so light. If you land with any impact at all, you bounce.
Right.
So that was the difficult part. And here's a picture from the surface.
Just have to tickle their way down.
I mean, this could be in Utah. And if you've ever seen the skies in Utah, you'll know they're the correct color here too.
In Utah at night, and it looks exactly like that.
Yeah, except maybe the land wouldn't be illuminated quite so much.
Oh yeah, okay.
Full moon.
This is the most active volcano in the solar system. It's Io's Pele, which is in a constant state of eruption. You're seeing a 190-mile high plume here.
Holy smokes.
It just looks like a little stream of water. And then you remember that, like, this is an entire moon that this is coming off of. Like, the scale of that.
And the largest known Natural satellite would be Ganymede, Jupiter's largest moon, 3,267 miles in diameter. Quite a bit larger than our moon, as you can see here.
Oh, yeah.
Almost Mars-sized and bigger than Mercury.
Mm-hmm.
And the largest known impact structure lies on Ganymede. You see the dark area here in this image. This is an impact structure that was determined to exist just this past August. And it was determined to be an impact structure from an examination of some of the terracing around the edges. It's 4,836 miles in diameter.
Must have hit another moon or something.
And what about the largest known storm? Everybody's thinking Great Red Spot, right? Well, currently, yes. But the largest known storm ever was the Great Springtime Storm on Saturn that roiled the Saturnian surface from the cloud tops from December of 2010 all the way to August of 2011. The storm itself covered 1.5 billion square miles.
Good Lord.
Eight times the Earth's surface in size. And here's a close-up of the bottom screens show the entire surface of Saturn at that latitude, and you can see the length of it, nearly wrapped completely around the planet.
It's beautiful.
Tallest known cliff in the solar system belongs to Verona Rupes on Miranda. It's 63,000 feet tall. It's about 12 miles tall. You can jump off of it and have a glorious ride to the bottom. It would take 12 minutes, but when you reach the bottom, you'll regret it. You'll land at 124 miles per hour. The furthest man-made object from us, of course, is Voyager 1. And Voyager now, which we're still in communication with, amazingly, lies at a distance of 14 billion miles, 1/2000th of a light year from us. And you see the orbits of all the planets here, and the trajectory.
Yeah.
Okay. The furthest photo of Earth ever taken was taken by Voyager 1 when it was 4 billion miles from Earth. So this is a view looking back at us from 4 billion miles, further than Neptune. And I will ask you now, Scott, I'm about to leave the solar system, so would you like to save the rest of this for later or continue?
Let's see what happens outside the solar system.
Let's see what happens, okay. Nearest star to the sun, of course, Proxima Centauri. You can certainly see it in this picture, can't you?
Yes.
Yeah, you can pick it out. There it is right there.
Yeah, I see it.
Yeah. It's a red dwarf, 4.25 light years. That's about 25 trillion miles. That's about 8,330 times further than Pluto. And this will give you some idea of scale. This on the left, you see the Earth and the Sun. They're not to scale as far as distance is concerned. Excuse me. This is merely showing you the size of the star compared to the star Proxima, which is much smaller. And Proxima Centauri has a planet, Proxima b, which is approximately the size of the Earth. This is an artistic representation only. That, of course, garnered significant interest from the astronomy community because it's the closest planet outside the solar system to us. And the trouble is, even though the view from Proxima b to Proxima Centauri would be roughly equivalent to that on Earth, Proxima Centauri is a flare star, and that would make life on Proxima b completely implausible. Yeah. Looking back from Proxima, however, the constellations would look the same. If you looked back from Proxima Centauri's vicinity toward the constellation of Cassiopeia, you would see one extra zag in the zigzag of Cassiopeia, and that would be the sun, approximately that bright. And speaking of which, what about the closest supernova remnant to us? Well, we're in the middle of one. It's called the local bubble. It was thought to relate to a supernova called Jaminga for a while, but new studies suggest that it was a supernova that occurred very close to us in the vicinity of the present location of the Pleiades. which is only 444 light years away. This is the most sun-like star that's ever been found. It's 18 Scorpii. Look at the comparison. Mass almost the same, luminosity the same, diameter the same, temperature the same, rotation rate virtually the same, age virtually the same. So if you want to go out and look at a star that you can see with your unaided eye, you'll see one that matches the sun almost perfectly. No planets have been detected around 18 Scorpii so far. Now, it's only 45 light years away, but bear in mind that in order to detect planets, you need some help. You have to have planets transiting across the face of the star. They might be orbiting in a circular pattern around it, you know, that we're looking down on from the North Pole of the orbit.
Yeah.
So we might not see that. The largest apparent diameter of a star seen from Earth belongs to R Doradus, which subtends an angle of 0.057 seconds of arc, slightly larger than Mira and Betelgeuse. And you can see how big these stars' angular diameters, apparent angular diameters, are in comparison with Pluto as seen from Earth.
Mm-hmm.
And those are actual star images at the top, by the way.
Huh.
The smallest known planet is this little world, Kepler 37b. It's roughly the size of Earth's moon. It orbits its star at a distance of, for the period of 13 days. The surface temperature is around about 800 degrees Fahrenheit on the surface. It's about 215 light years away. And the largest known planet, if it is one, is HD 100546b. Lies 320 light years away. It's about 7 times the mass of Jupiter. But at some point, it's really hard to define the boundary between a planet and a star. If Jupiter were more massive, it would become a brown dwarf. If it were even more massive still, a red dwarf. And making the cutoff between the two is very difficult. This is more than likely a brown dwarf. The darkest known planet is TRES-2b. It orbits a star called Kepler-1 in Draco, and it's slightly larger than Jupiter, and it reflects only about 4% of the light that hits it.
Huh.
This is sometimes considered to be the most symmetrical deep sky object known. It's the red rectangle in Monoceros at 2,300 light years. Look at the patterns. I mean, the shock patterns on all sides are virtually identical.
It looks like a gem.
Yeah. The most planets around a star, well, we used to hold the record until Pluto got demoted. And now we're in the tie with Kepler 90. It has 8 planets that orbit very close to its star. In fact, all 8 of their planets, of Kepler 90's planets, orbit inside the distance of the Earth's orbit here. And
oh, it's a nice bow tie.
This is the coldest place in the universe known. It's the Boomerang Nebula in Centaurus, and it's expanding so fast that it has cooled its gas at the center to only 1 degree Kelvin. It's releasing its gases at about 310,000 miles per hour. And this nebula lies at a distance of 5,000 light years.
Wow.
And here we have the hottest known star. This is a Wolf-Rayet star, 102, WR102 in Sagittarius. It has a radius about 60% that of the sun, and its surface temperature, I'll tell you, the sun's surface temperature runs about 10,000 degrees Fahrenheit. This star, the surface temperature is 378,000 degrees Fahrenheit.
Cool.
And this is the little dot in the bottom is the fastest spinning pulsar. It's a neutron star that rotates 716 times per second. That means that the equator of this neutron star is rotating at 24% the speed of light.
Wow.
And only gravity that strong could hold it together, spinning that fast, of course. This is the largest known star. It is Stephenson 218 in Scutum. It has a diameter of 1.8 billion miles. And to give you some comparison, what you're looking at here is the orbit of the Earth around the sun at the left compared to the surface of Stephenson 218.
Oh my God.
Whoa.
It's a big, big jumbo star. Look at that.
And here we have the fastest moving star. This is an image of stars rotating around, orbiting rather, the central black hole, Sagittarius A star, at the center of the Milky Way galaxy. And the fastest moving star detected in this group is moving at 8% the speed of light in a very tight orbit around that center. So strong is the gravitational attraction of that black hole. The closest galaxy to the Milky Way, the Canis Major galaxy, which is actually already entwined with our own. These stars have been categorized and traced and form a pattern like this. It's already being absorbed by the Milky Way. Its nucleus has a defined location, however, its former nucleus here. Sometimes, yeah. This is the fastest spinning star. It's an artist's conception, of course, called VFTS 102 in the Large Magellanic Cloud. It's rotating 1 million miles per hour at the equator. It's about 100 times faster than the sun. And stars of this type, that is not neutron stars, but ordinary stars, can only rotate so fast before they fly apart. The largest known spiral galaxy is the Condor galaxy, NGC 6872 in Pavo. Lies at a distance of 522,000 light years and is 212 million light years. It's 212 million light years away and 522,000 light years from tip to tip. 500 million light years from tip to tip. And this is the largest known galaxy. It is IC 1101 in Virgo. It has approximately 100 trillion stars. That's about 500 times more stars than the Milky Way. And its halo is approximately 4 million light years wide. That is greater than the distance between the Milky Way and Andromeda. And it lies at a distance of about 1 billion light years from us. And the largest known structure in the universe is the huge, large quasar group. I'm not kidding, that's what they call it, because there's a large quasar group, but this one's the huge one.
Astronomers are so good at naming things. The Very Large Array.
What are you going to call it? I don't know, call it huge and large.
Exactly. Like,
Huge, large.
This happened with the large telescopes. You know, they had the large telescope and then the overwhelmingly large telescope and so forth.
You're going to run out of superlatives at some point, right?
Yeah. This consists of 73 quasars in Leo and Leo Minor, and the chain is associated with it's about 4 billion light years long. The hottest place in the universe is in a galaxy cluster called RX J1347, another really clever name, in Virgo. And it's a cloud of gas that has been determined to have a temperature of 300 million degrees Kelvin. It's about 5 billion light years away. The most massive galaxy cluster known is in the constellation of Phoenix. It lies at a distance of 7 billion light years, has 3 quadrillion suns worth of stars in the galaxies that form the cluster.
Wow.
I guess political correctness hasn't reached this particular galaxy yet because astronomers call it El Gordo, which means the fat one. That's the name of it. The largest known black hole, TON 618 in Canis Venatici. The black hole has a mass of 66 billion solar masses and a diameter of 240 billion miles. It's 1/25th of a light year, and you see Neptune's orbit in the middle of it.
Look at that.
The furthest known galaxy is the brightest known object in the universe is quasar APM 08279525 and links. Now this one's interesting because it's a magnitude 15.2. It's accessible to amateur instruments. And lies at a distance of 12 billion light years. Light's only had about 13.4 billion years since galaxies began to form, 400 million years after the Big Bang, in which to reach us. So you're looking here at virtually 90+% the distance to the furthest object that light would have had time to reach us from. This galaxy is rather interesting because it's the largest known repository. This quasar is the largest known repository of water known to exist in the universe. And the furthest galaxy ever imaged is GNZ11. The Hubble Space Telescope took this image. We're looking here at an object whose light has traveled to us for 13.4 billion years. You read the reports that say it's 13.4 billion light years away. Of course, that's not where it is today, because the whole time that light's been traveling to us, the universe has been expanding. So today, this galaxy is actually a mature, much larger galaxy that's merged with others, and it lies at 32 billion light years. But this is the furthest one in terms of light travel time ever imaged. It's so new that this object is only about 600 light years wide, has only about 1 billion stars in it. So you're seeing a brand new galaxy that is forming. And of course, that takes us pretty much out as far as we can go, and I'll terminate it right there.
Right.
I think it's amazing that we can see that, like all those, especially all those distant things from Earth, just with our little humble, not cosmologically sized telescopes, yeah, that might include the Hubble, but that's still not a massive telescope,
Right.
It's amazing.
And there's so much more to do, so much more to see. So
James Webb Space Telescope.
yes. Get that thing up there.
Please.
Someday.
Eventually.
Cross fingers.
All right, folks. Well, I do think that will conclude it. That was a great ending to a great start party. Chuck, thank you so much.
You're welcome. Thank you.
Thank you. You guys have a good night.
You
Mike,
too.
thanks for joining. Molly, of course. Richard, Dee, thank you again for joining.
Good night.
See you all. And of course, our audience, thank you very much.
Night.
Good night.
Like, share, and subscribe.
Good night, you.
Like, share, and subscribe. That's right.
Like,
And pet your kitty.
And pet your kitty or your dog if you have one.